Good morning. We'd like to get started here in just a minute, so if everybody could take their seats. My name's Cecilia Solhoff, and I'm an outreach specialist in the Wireless Bureau here at the FCC. I want to thank everybody for coming today. Big thank you to all the speakers who traveled to be here. There's a couple of housekeeping things that we need to go over real quick before we start. We are broadcasting this workshop live on the web today. Those of you watching remotely can submit questions for the panels by sending an email to livequestions, livequestions, @fcc.gov. Those of you in the audience today, we're going to collect note cards on questions on note cards. So in the back of the room here, there's an agenda, the speaker bios, some note cards and pens. We are asking that when you submit your questions, both through email or on the note cards, that you include your name and the organization or company that you're affiliated with along with your question. As time constraints and the volume of questions allow, the moderators will try to get to as many questions as possible. Also, there is a sign-in sheet in the back, so if you haven't already done that, we'd like you to please sign in today. Now, to get us started, I'd like to introduce Rick Kaplan, who is the Chief of the Wireless Telecommunications Bureau here at the FCC.
Good morning. Oh, that was good. Nice. As Cecilia said, I'm Rick Kaplan, the Chief of the FCC's Wireless Telecommunications Bureau. It's my great pleasure to welcome you to today's forum on distributed antenna systems and small cell solutions, co-hosted by the Wireless Bureau, the Wireline Competition Bureau, and NATOA. As I'm sure you're well aware, Chairman Janikowski's top priority is increasing the reach and scope of mobile broadband. Mobile broadband has the power to create economic opportunity, increase civic participation in government, improve education, and for better or worse, improve our being in touch with family and friends. At the FCC, the staff is working hard to identify and reallocate additional spectrum that can be used to provide mobile broadband. We are making progress, but this is not an easy task. Moreover, finding new spectrum opportunities is just not enough. With smartphone and tablet sales going off the charts, our efforts must be comprehensive. And in order to meet this challenge, we must also deploy mobile broadband infrastructures that take the fullest advantage of the spectrum we have available today. One proven method for doing so is through the deployment of distributed antenna systems and small cell networks. Working with NATOA, we have been able to bring together representatives of companies that have successfully deployed DAS and small cell networks with the organizations and communities that host these networks. Together, they will provide an overview of the many ways these technologies can be used. Our aim today is for everyone participating in this forum, whether here in this room or live via the internet, will come away not only with a better understanding of DAS and small cell technologies, but also with the information necessary to get started with deployments in your own communities. So once again, thank you for being here today, and thanks to everyone who has made it possible, especially the Wireless Bureau's Dan Abeda, Don Johnson, Cecilia Solhoff, Charles Mathias, who have played key roles in organizing today's event with a terrific turnout. I now have the distinct honor, of introducing Sharon Gillette, the Chief of the Wireline Bureau at the FCC. Sharon has been instrumental in quarterbacking the Chairman's Broadband Acceleration Initiative, and in particular, the Commission's efforts to facilitate the use of existing infrastructures for broadband. Sharon?
Thanks so much, Rick, and it's great to see so many of you here today. In case any of you are wondering what the Wireline Competition Bureau has to do with distributed antennas and wireless technology, it has to do with the fact that we oversee the pole attachment rules from Section 224 of the Communications Act. Those turn out to be, as most of you know, pretty important to the deployment of DAS in our country. When as most of you know, I was a state commissioner in Massachusetts before I came here, and the very, very, very first thing that people told me when I arrived there is if you want more broadband in Massachusetts, you have to allow us to get on poles because it's really hard and it's really long and complicated, and sometimes people just say no. And so that was an issue that was very fresh on my mind coming here at the FCC. And as you know, we reached an order on that issue last April. And the report and order on pole attachments recognized the growing importance of DAS deployment. And among other things, it clarified that good old Section 224 does allow wireless attachers access to pole tops. And the feedback we've had from DAS providers on that decision has been very positive. I would also say that we always welcome data here at the FCC, and to the extent any of you are seeing an impact that decision has had on your businesses, we welcome any data, and we also welcome anecdote stories of the impact that has had on deployments of DAS and mobile broadband more generally. So send those stories and send in those numbers. We love to get them. It's also true that in that proceeding we learned a lot about what states and localities have done, and we hope that the order can be helpful to some of the, we pass an order. In the real world it has to be implemented, grappled with, dealt with between people and companies. So what we took away as blanket prohibitions aren't really appropriate, but we understand that in the real world there's all sorts of real world constraints. So when the engineers start talking to each other, sometimes the workable solutions can be found, and I'm very much looking forward to this and a series of workshops looking at how DAS fits in with local government and property owners' review processes and where any information gaps may need to be bridged. I'm very, very pleased to introduce our next speaker, who is Joanne Hovis, the president of NATOA and an old friend. Take it away, Joanne.
Thank you, Sharon. It's really a pleasure to be here. Thank you, Sharon and Rick, and all our colleagues at the FCC, particularly Jeff and Dawn, Cecilia, Dan, and Charles. NATOA is just delighted to be able to work with the FCC on educational efforts and on attempts to collaborate and make sure that our communities and our partners in the private sector are working together and understanding each other's needs. And today's event represents an enormous amount of work by the Commission. We're grateful to them and for the opportunity to have this ongoing conversation with our partners in the private sector. We recognize the importance of this technology and its incredible power, its great flexibility, and how significant it can be in our local communities throughout the United States in making sure that services are deployed in the best and most efficient possible way for our residents, for our consumers. And the importance of broadband and communications technology and its deployment is not in any way lost on America's local communities. Quite the contrary. No one recognizes more how great the desire and demand for these technologies is at the local level than local elected officials and local officials who deal with day-to-day questions from consumers. We, as local communities, are totally committed to the deployment of broadband. In fact, I'd say we've been extremely innovative for more than a decade in trying to find new and creative ways to bring services, wireless and wireline, into our communities. And one of those most important ways is collaborating with the private sector and working together. We also respect the needs of private sector providers and the parameters around what they can and will do. And we hope that as we learn more about the technology and as we're able to work together more to understand each other's needs, we will see swifter, quicker, less painful processes, and that we can work on best practices together in a collaborative and a voluntary way. So we are thanking you all for being here, our partners in both the public and the private sector, and really look forward to ways to expand. From our perspective, the keys to that and to successful deployment are mutual respect, mutual understanding of each other's needs and concerns and interests, and collaboration. And we hope to continue that process of collaboration. NTOA is always open to a process of collaboration and mutual education with our private sector partners in any circumstance and at any time. So let me make that an open invitation. Thank you very much for being here and for having us here. And I believe I will just hand it back. Thank you.
Thank you. Thank you, Joanne. We're going to now have a DVD, a videotaped greeting from Ken Fellman, who is a member of the FCC's Technological Advisory Council. And I'd also like to say real quick that we are having some issues with, some technical issues with the webcast. People are able to hear it and not see it, and we are aware of it, and we are looking at it for those of you remotely watching or trying to watch. And now we're going to have the greeting from Ken Fellman.
On behalf of the Intergovernmental Advisory Committee to the Federal Communications Commission, welcome to today's workshop on small cell technologies and distributed antenna systems, or DAS. The current Intergovernmental Advisory Committee is relatively new. We are comprised of state, local, and tribal government officials from throughout the United States. One of our goals is to advise and help educate the FCC about the communications needs of state, local, and tribal governments. Today's workshop about DAS is one piece of a much larger puzzle related to broadband deployment, broadband availability, and broadband adoption throughout the United States. I serve as the city attorney in Cherry Hills Village, Colorado, a small suburban community south of Denver. We first had an opportunity to work with a DAS system and a DAS provider back in 2008 and 2009, before we knew that the technology was even called DAS. We worked out a right-of-way agreement to place facilities in city-owned right-of-way on poles owned by a private investor-owned utility. Most of these individual attachments are addressed through an administrative approval process, which is faster and less costly than the public hearings traditionally found in rezonings. While we didn't know that we were probably one of the first Colorado communities dealing with a DAS system, here's what we did know. This was a new technology. It was not visually obtrusive, and it provided opportunities to obtain significantly better wireless coverage in a predominantly residential community where siting towers is very difficult. The point here is that smaller antennas on lower facilities, things like streetlight poles and traffic signal poles, this is an important technology not just for the providers, but for all levels of government. Another jurisdiction represented on the IAC is New York City. New York City has had some recent experience with small cell technologies and has granted a half dozen or so franchise agreements. Considering its population and the demand for wireless services, New York actually has a limited number of city-owned poles. These franchises create a fair and efficient allocation of the limited number of streetlight poles that exist. All of these franchise agreements have rules about the size of the equipment that can be installed and where on the poles it can be installed. Companies must test for compliance with the FCC's radio frequency limits when the city requests. Now, every community is different. What works in New York or in Cherry Hills Village, Colorado may not work for you. Today's workshop will help educate all of us about what DAS is, how it's already being used effectively in a variety of settings, and what we can do to incorporate it into our communities throughout the country. The Intergovernmental Advisory Committee thanks the FCC and the National Association of Telecommunications Officers and Advisors for hosting today's workshop. We believe that with better education about DAS and small cell technologies and mutual respect by industry and government about the legitimate needs of both sides, these technologies can help us achieve a successful broadband future. Thank you.
And our final opening remarks will be from Dennis Roberson, who is a member of the FCC's Intergovernmental Advisory Committee. Dennis is going to be joining us via conference call or bridge phone, so you'll be able to hear him but not see him.
Good morning and welcome. I'm delighted to be here, and actually I am representing the FCC's Technology or Technical Advisory Committee, so a little transition or transposition in the affiliations between the last speaker and myself. But I am delighted to welcome you all to this DAS Small Cell Forum. I think it will be an outstanding day for all of us. Though I am not with you physically, I am with you over the internet and observing the backs of many of your heads right at this moment. The work of the Technical Advisory Council has been divided in the last year on a variety of topics, and I had the great pleasure of chairing the working group on spectrum efficiency. One component, and critical component, of that work was the focus on meeting the needs, and in fact the increasingly important needs, of satisfying wireless broadband requirements for high teledensity areas. This is exactly the area where small cells and distributed antenna systems really apply. To put this into a rather colorful context, we all face what I will describe as the quadruple whammy. The challenge of dealing with an ever-increasing number of applications, dealing with the challenge associated with the wide adoption and popularity of those applications, dealing with the performance requirements as the applications become ever more exotic and have greater human interface requirements, and finally dealing with the extended periods of time that these applications are used on a daily basis. So putting that together into this colorfully described quadruple whammy, and now putting it into the context of high density population areas, it's virtually impossible for the service providers to meet the needs of large groups of people without the application of a new and improved way of dealing with the problem. That solution comes in two flavors, as we'll discuss through the day, and that is the distributed antenna system that has been already mentioned probably most, and the small cell, the application of femtocells provided by the carriers, and increasingly new opportunities in that area for municipally provided capabilities or building provided capabilities that would provide for much greater indoor coverage and indoor capacity, again, especially for high teledensity environments. It's going to be critically important for you to evaluate these solutions and to understand them carefully. The solutions, while they are extremely appealing and in fact do provide a significant measure of the solution, they are also complex solutions. The wireless area is always an area that some have characterized as pure magic, in that there is the interrelationship between the various transmitters involved in providing capabilities. So there is a need for including experts in this area in your planning for your various communities. There's also an important requirement for engaging the service providers themselves, since the solution, the small cell or DAS solution, will need to operate in an environment that has existing occupants, and those need to be dealt with properly. But when that is accomplished, you do have the promise of a much improved solution to this quadruple whammy problem, providing much better wireless broadband access to the citizens of your communities. And this, of course, is highly desirable and is a goal for all of us. So thank you again for your attendance, your involvement. Thank you to the FCC for hosting the event, along with the National Association of Telecommunications Officers and Advisors. I trust that this will be a terrific day for all of us. Thank you all.
Thank you, Dennis. So as a reminder for those who might have come in during the opening remarks, we do have a sign-in sheet and some handouts at the back table over here, and note cards and pens if you'd like to submit questions during the day. The way this is going to work is we're going to have 2 panels in the morning and then a lunch speaker with some time for you to go get your lunch and come back to the room here and hear the lunch speaker, and then a panel in the afternoon. The first panel is going to be a brief introduction into DAS and small cell technologies. There will not be questions and answers for the first panel. The second and third panels will be more interactive. The panels today are going to cover how distributed antenna systems and small cell solutions can expand mobile broadband coverage both inside buildings and outdoors. The panelists will discuss the technology of DAS and small cell solutions, the benefits these systems can provide, and how they have made these solutions work in different settings. The panels are not going to cover regulatory issues that are before the FCC, the courts, local governments, or state public service commissions. So with that, we'd like to ask the panelists for the first session to come forward, please. And the bios and presentations given today will be posted on the FCC website. If you go to www.fcc.gov/events, and there's a button that will say past events. Click on that button and then look for the forum, and you can get the presentations there. So as I said, the first panel today is going to be a brief overview of DAS and small cell solutions. The 5 panelists today are Alan Dixon, who is a business development manager at Corning Mobile Access, Noreen Luker, who is the senior director, utility administration at NextG Networks, Inc., Stephen Garcia, who is senior manager of land use external affairs at Crown Castle, and James Seymour, Senior Director, Wireless CTO Organization at Alcatel-Lucent, and finally Alex Gamoda, Vice President for DAS Real Estate at American Towers. And I have
waiting for my presentation to show up. There we go. Okay. Good morning. I'd like to thank the FCC and NATOLA on behalf of myself and the rest of the panelists for giving us an opportunity to speak to you today. What we hope to accomplish with this panel is to give you an idea of what distributed antenna systems are, why DAS is important, how to build a DAS, and then talk about some factors affecting deployment of DAS from both a regulatory and from a business perspective. So let's get started. So if you see up here on the screen, the first thing you see is a definition of a distributed antenna system. This is the kind of definition that you get when you lock 15 engineers in a room and you ask them to define a DAS. And that's what we did with the DAS forum. So what I'm going to do is try to bring this down a little bit. A distributed antenna system, a DAS, is nothing more than an RF source connected to multiple antennas distributed across a large area. So that could be a neighborhood or it could be a building. But it's real simple. So we've got an RF source connected to multiple antennas distributed across a large area. The first graphic you see there at the bottom of the screen on the left-hand side is from our friends at Extenet, and it illustrates what a DAS could look like in an outdoor environment. So what you see is a base station hotel. That's where our RF source is going to sit. And then you see multiple utility poles which could house antennas. And so now we've got our RF source connected to multiple antennas across a large area, which is that neighborhood that's represented there. If you want to take that indoors, it's a simple matter of now we're going to take and go vertical instead of horizontal. So we're going to have a base station that's going to sit inside the building. We're going to have single mode fiber that runs up the riser, and then we're going to have antennas that are distributed on the floors of the building. So again, RF source connected to multiple antennas distributed throughout the structure. So that's the recurring theme of a DAS.
A DAS can be simple, so it can be a single operator that comes in and installs this, so they've got their RF source and their multiple antennas, or it can be increasingly complex by adding layers to it. We could support multiple wireless providers. We can support multiple services. We could add public safety to this. There's a lot of different things that you can do, but the fundamentals remain the same. RF source, multiple antennas, distributed across a large area. So here's a quick history of DAS. DAS sort of arose out of the roots of some programs that the military was working on, where they were taking RF and converting it into optical signals so they could develop the phased array radars that came into being back in the 70s. It was a simple matter once you got engineers turned on to this concept of being able to take that now, instead of using it for radar and being able to identify targets, is use RF, which is the same spectrum that we're using in telecommunications, and develop that to distribute RF signals for communications purposes. In fact, Dr. A.A. Saleh introduced that in 1987 with a paper to the IEEE. It wasn't long after that somebody put it into commercial practice. And in 1989, the first commercial analog fiber DAS was installed up in Chicago area. A couple years later, our friends at ADC at the time introduced the first digital fiber optic DAS, and that went in 1993. And so, of course, today we see all kinds of DAS networks being deployed indoors and outdoors, both digital and analog, all the way across the country. So there's several benefits of DAS. You'll see them listed up here on the screen. I'm going to focus on the first two and the last two. The first is coverage. DAS provides coverage in areas that are underserved by traditional sites, and that can be for a lot of different reasons. It can be because of geography. If you look at some of the natural canyons that are formed out in the western half of the United States, it's almost impossible to serve those with a traditional cell tower, because you set the cell tower up and it just blows the signal across the roadway. It never gets down to the area where the people live and the people drive. And so DAS is good for now extending that coverage into that geographic canyon, or that natural canyon. But we create man-made canyons all the time. So if you look at dense urban environments, if you look at the downtown areas of New York City, of Chicago, Los Angeles, pretty much any large city, what you have are these concrete and steel canyons that you create on your own. And you get the same kind of challenges. If you put a tower on a rooftop, it's difficult to get that signal to penetrate down to the ground level where your consumers are. So DAS provides an opportunity to provide service into that man-made canyon. You also have areas that are underserved because of regulatory issues. You've got neighborhood associations, or you've got municipalities who are reluctant to allow a traditional DAS or a traditional cell tower to be located in their area. And so what you end up is having to put that cell tower back away from those consumers, and then you service across a larger area. And that makes it difficult to reach some of those folks. Capacity is another issue. We're going to talk a little bit about the change in wireless that's coming up and the change in user devices. But capacity is becoming an incredibly huge obstacle to overcome, and you'll see why in just a couple of minutes. But DAS allows us to manage that capacity a little bit more carefully. Because we're getting closer to the consumer, we can direct the capacity to where the users are. If you've got an area where you've got that cell tower now sitting back away from the community, there's a possibility that you're broadcasting that signal across a large expanse of open field or area where there's absolutely nobody. There are no users involved. And so you're wasting that space or wasting that energy on those areas. DAS allows you to target the capacity that you need and get the cells, the smaller cells, closer to the customer. Down at the bottom, you see scalability. DAS is a very scalable network. So what you can do is you can service a room in a building, you can service a floor in a building, you can service a building, a campus, you can expand it to do a community, because the whole principle stays the same. It's just a function of how much equipment that you want to put into it. If you've got a single carrier, you can add multiple carriers. If you're running cellular services, you can add additional services to it. So DAS is very scalable. It's very adaptable. It doesn't matter, well, it does matter. Once you've got the technology in place, it's a simple matter of changing out end equipment to provide additional services, because the infrastructure stays the same regardless of the service that it's going to be carrying. It's just RF converted into optical and then moved across to the antennas and converted back on the other end. So if we want to do a quick comparison of a DAS to a macro site, this just gives you a little bit more of a visual index to be able to do that. On the top, what you'll see is both a graphical representation and a photograph of a standard cell tower. And then at the bottom, you'll see a distributed antenna system represented the same way, both graphically and pictorially. The first thing that you see is the cell tower. This is the thing that we've seen, basically since the advent of towers started coming out. So about 150 to 200 feet tall. and very, very visible. On the other hand, if you drop down to the picture on the bottom, you'll see that this is an antenna that's attached to a light pole. We can also attach to utility poles. We've attached to stop signs. There are lots of different ways that you can do it, but the fundamental thing is it's a much lower antenna height than what you're used to seeing with a traditional cell tower, and therefore it's a lot less visible. The other thing that you get away from is the relationship of base station to cell site. So with a conventional cell tower, you have a base station for each carrier that's on the property. It's fenced in, and then you've got cables that run up to the antennas that service that cell site. But the relationship is one base station, one cell site. With DAS, we take those base stations and we put them into a base station hotel, just a place where we can collect all those RF sources. And then we use them to support multiple antenna sites. So you get lots of different places. So you can support up to 40 different DAS nodes off of the same base station. So that relationship becomes now one-to-many as opposed to one-to-one. So drivers for DAS. The original macro network was designed and has historically been used to support people who are traveling between buildings. So it's aimed at pedestrians, it's aimed at drivers that are at a height of somewhere between 4 and 6 feet who are on their way somewhere. The initial thought for the macro network was we were going to service the outdoors because the indoors had these things called desk phones. And so when you got to your office, you would use your desk phone and you wouldn't use your cell phone. Well, things have been overwhelmed by events, and now we have to address that. But for the most part, what you had was a macro network that serviced 80% of the users, and so it got 80% of the capacity. You would get some large buildings that the carriers would agree to cover with an indoor coverage, but for the most part, we were focusing on the outdoors with the macro network. The other thing that you keep in mind is that these were along well-traveled routes. So we were aiming at the customers who were using this. And beginning in 1985, when the first cell systems first came out, wireless was kind of the purview of the rich and the business traveler, the rich person and the business traveler. So it wasn't until the last 5-10 years that we've started to get a ubiquitous presence for wireless for everybody. So what you have is these routes that have been built up, and you've got these underserved areas that have not really benefited from the macro. And it's those folks are now requiring service. So there's some things that we're doing there. So this is how DAS can help in that type of an environment. So this is a graphic that our friends at TE Connectivity provided us, and it's a really good for illustrating this. So what you have is a network that's existing today, and it's covering the areas that are represented by the hexagonal grids that you see up there. You've got your cell towers out there. They're represented by the red dots, and so the coverage would fill those adjacent spaces to the red dots. But networks only work with the technology that they have today. And if you upgrade those networks, you're going to see changes in the way the network reacts. So if you take an 850 megahertz and now you upgrade to 1900 or to the AWS band, what you're going to see is that cell site now doesn't service the same area. You're going to drop in the size of the area that's covered, and you can see that in the light green. So you can see that the light green now covers less of the grid than the original technology did. And that opens up these interstitial areas inside the coverage areas. So they were once covered, but now because we've upgraded the technology, we changed spectrum, those folks are no longer covered. DAS gives you the opportunity to use those existing cell sites and spin off of that, either feeding it from a base station hotel or from the cell site, to fill those interstitial areas without having to put in additional cell sites, big cell sites, macro sites. This is also a great way to get into those underserved communities. So if you've got that urban core that historically has suffered from not having good cell phone service, what you can do is create your base station or hotel somewhere and then run the DAS into that area and provide service for those people who are really starving for wireless service and for bandwidth. But there are changes that are happening in the wireless world. And this is sort of a collection of factoids that kind of illustrate that. One of the things is we got wireless penetration approaching 100%. So pretty much every man, woman, and child who wants a cell phone pretty much has one today. They not only have cell phones, they have smartphones, and we'll see what the impact of that is. The other thing is you've got wireless households that are making up about 30% of the population. So you've got people who have completely cut their attachment to the landline. And so that creates new challenges. How do we get information to those folks? But more importantly, if you've approached 100% saturation with providing cell phones to the people that are walking around and driving around out there, you're pretty much topped out. You should be able to build a network that services that. But the problem is that we've got this new collection of devices that the carriers call connected devices, and they're making up the majority of growth in the U.S. And these are things like tablets, e-readers, your Nooks, your Kindles, this Wi-Fi hotspots that connect to your cell phone or to your laptop, machine-to-machine communications. And at the end of 2010, the wireless carriers predicted that those would make up 10% of the growth in the marketplace by the end of 2011. And we've seen that really come true in a big way. What's unique about that is that these devices are not really being used the way that the macro network has historically been set up. The average consumer spends 50 to 60% of their time in an indoor environment. In fact, one large carrier in the U.S. told us that 80% of all worldwide data connections initiate inside a building. These new family of devices, these connected devices, are data devices. They're going out to the internet. They're using these things for several different things, which you can see on the left-hand side. 200,000 text messages being sent every second. 35 hours of video being uploaded to YouTube every minute. And by the time a 21-year-old reaches that age, that person has spent an approximately 10,000 hours on a mobile phone, checking in on Foursquare, updating their status on Facebook, all doing these from mobile devices. But the important thing is for the most part, this data consumption is a uniquely indoor phenomena. Because remember, we focused our macro on the outdoor network, so now what we've got to do is provide service to people who are inside the buildings. So that's what we're looking at today, is using distributed antenna systems to provide that coverage and that capacity to the 80% of the users who are now inside the building and historically have only received about 20% of the coverage. Does that mean that we can do away with the macro network? Absolutely not. Because when that whistle blows at 5 o'clock and somebody yells yabba dabba doo, all those people are leaving those buildings. And they're going to get in their cars or they're going to walk the sidewalks and they're going to go from one place to another. So DAS serves as a complement to the existing macro network. It's one of the tools that can be used by the carriers to provide coverage and capacity to the users. So this is another a great little slide that we use, collected this from Cisco's Visual Networking Index. This is talking about the devices that we originally discussed on 2 slides back. So if you look at the graph, what it's showing is data consumption. It's not the number of devices sold, it's the data consumption by these devices. So if you look at that green bar, that's our family of connected devices. And that's the data that those things are starting to, that they're forecasted to consume in terms of terabits. In fact, one of the major carriers told us that their data use on their network has increased 8,000% for the period from 2007 to 2010. That's a tremendous amount of impact, and if you look at the graphic to the right, you can understand why. A standard smartphone is the equivalent of firing up 24 regular phones. Now, when we say regular phone, that's a phone that you can actually make a phone call on, maybe send a text message. It doesn't include the web browsing. So once you bring web browsing and that sort of thing into it, it's the equivalent of turning on 24 regular phones in a service area. Skip down a little bit to the tablets, those things that we're all fascinated with these days, whether they're Android or Apple driven. It's the equivalent of turning on 122 cell phones in a particular service area. And now if you want to skip ahead to a laptop that's enabled with a 4G dongle or that one of those personal Wi-Fi hotspots that you could hook up to it, it's the equivalent of 500 cell phones. That sort of drives home the change that we're talking about, is data is now king, and it's all about the data. I was fortunate enough to sit with a guy named Sunil Prasad who worked at Nextel at the time in 2005 on a panel, and we were talking about why DAS was important back then. And Sunil said that it's data that makes DAS inevitable. So it makes him a pretty good profit. Now, before you run to him and try to hire him for your company, he also said that DAS should be free and invisible. So we're working on one thing at a time. But the important thing about DAS and the important thing about data is that you've got to have a better signal to be able to make this thing and work properly and make it work well for everybody. And smaller cells like DAS provide the keys to be able to provide that reliable high-speed data delivery. And that's one, get the user closer to the source. That's why that smaller cell is important, because we want to keep that roll-off from happening as we move away from the source. And limit the number of users in the cell, because wireless bandwidth is shared bandwidth. And if you can combine those two things, you can provide reliable and ubiquitous high-speed data coverage. So what are the DAS value proposition? We've kind of talked around it, going to kind of sum it up right here. There are benefits to the end user. Better voice quality, fewer dropped calls, faster internet access, longer battery life because their devices aren't working as hard to talk to the network. Seamless handoffs, and then no dead zones. The benefits to the venue owner. The reduced customer complaints about wireless service. I don't know how many of you are business travelers, but there's nothing more frustrating than checking into a hotel and finding out you can't use your phone. You get the wireless access. And it provides a competitive advantage for obtaining and retaining those customers. And then there's benefits to the wireless carriers: increased customer satisfaction and lower churn, dedicated coverage and capacity for that facility, multi-carrier, multi-band, multi-technology solution that offloads traffic from the macro and makes it more efficient, and solves that tall building problem, all those people being clustered together in urban environments. The other thing is you can take back and revisit this a little bit. So we talked about the benefits to the venue owner, but you can change venue owner to the community. And if you change it to the community, you get an entirely different perspective on the way that DAS is being used. Because if now we can reduce the customer complaints about wireless service in the community. Folks want to be able to use their wireless devices. We talked about that 30% of the U.S. that's actually cut the wireline cord. This is their way of getting broadband access into their homes, a lot of them. And that allows you to retain customers, citizens, people who pay taxes in your community, in your area. And it could seriously make the difference between a community going boom or going bust, is making sure that they've got the opportunity to have that kind of wireless service so that businesses stay in town and the consumers stay in town. So a quick summary. What's our DAS? A DAS, again, it's nothing more than an RF source connected to multiple antennas distributed across a geographic area or structure. It can be simple, it can be complex. It can be one carrier, it can be multiple carriers. It can carry cell service, it can carry public safety, it can carry 800 megahertz trunk radio. There's a lot of different things it can do, but the fundamental principles remain the same. There are new connected devices, there are new wireless technologies out there, and DAS that all combine together to provide a very powerful tool to allow communities to retain customers and to bridge that digital divide in a lot of different places. And it scratches a lot of itches. It provides benefits that match up well for the end user, for the venue, and for the carrier.
Thanks, Alan. So I'm from NextG Networks, and I'm going to talk a little bit about the past 10 years of experience that we've had building outdoor distributed antenna systems and how that's brought broadband capacity to communities. And how do I make that full screen? Thank you. So NextG is a premier distributed antenna system provider. We've installed over 7,000 small cell sites in distributed antenna systems across the United States. And we've accumulated a very long record of safe and reliable installations. As Alan alluded to, and more developing from our perspective, the explosive use of smartphones and tablets is what's driving wireless operators to use more small cell sites, because small cells are the best way to deliver the data performance users are demanding. Placing cells on utility poles close to the user increased the performance, conservatively speaking, 10 times. Recently, at NextG, we've seen the biggest growth in the area of capacity to underserved areas, working class neighborhoods, universities, other areas where people are working and living. Now, if you're going to build anything, you got to start with the foundation. So there's three parts to the foundation of building outdoor DAS. The first thing is access to right-of-way and infrastructure. The Telecommunications Act of 1996 gave telecommunications providers that access. The next piece is engineering expertise. Outdoor DAS design is a highly skilled, multidisciplinary effort that incorporates RF design, fiber design, expertise in all safety, engineering, and construction standards applicable to the infrastructure being attached to or used. This can include OET 65, the National Electrical Safety Code, the National Electrical Code, GO 95, OSHA, Telcordia Blue Book, just to name a few of the standards you need to be familiar with if you're going to work in this arena. Finally, every area that you are planning a network for might have additional requirements. It's going to affect placement of sites, things like right-of-way setbacks, location of other utilities, historical area restrictions, and area-specific engineering standards developed by the infrastructure owners. Let's talk a little bit about the design. Designing a DAS network is kind of a painstaking process. You're going to meet the capacity or coverage needs of a wireless carrier customer by finding precise locations that meet all of the performance requirements, the safety requirements, and the polar requirements, and add on top of that a regard for aesthetics. The size of the equipment, the location of the equipment on the pole, and the pole location itself all must meet multiple criteria for a successful solution. So this design process can go through multiple iterations before anybody outside the company ever even sees it. We'll talk a little bit about the components of a DAS network. On this figure, you're going to see red dots that show the small cell site locations. The pink lines are the fiber routes along city streets and public way that reach the red dots, and this all connects back to that base station where the larger equipment is located, typically outside of public view. Breaking down the components a little bit, we'll start with fiber construction. Now, this is nothing new to communities. Fiber installations have been done for years. Aerial fiber cable is either installed next to telephone cables, strung pole to pole after you obtain all the necessary permits. Sometimes we utilize buried fiber cable, and where existing conduits do not have that room for new cable, new conduits are installed in trenches in accordance with standard permitting requirements. This is a key way to increase broadband capacity in a community all by itself. Let's talk a little bit about the small cell sites. Pole top antennas are actually a really good solution for achieving optimal coverage while minimizing the number of sites that you need to cover an area. There's a balancing act between providing capacity and not proliferating antennas to the point where it's not manageable. Pole top installation work can be done in a similar manner to any utility work in the public right-of-way, following all the regular traffic control and permitting requirements. With that said, however, if you're going to install and maintain antennas above utility lines, it's really important that you closely coordinate with the power company, following each individual company's safety procedures and standards scrupulously. Fortunately, many power companies develop procedures for their own antennas that form a good starting point. And another good piece of news is that the extra time and experience we used to experience in working with some utilities has been minimized significantly in FCC states with the issuance of FCC Order 1150. This has clarified regulations, and it's helped us work much more collaboratively with our fellow utilities. Still, with that in mind, though, poles are reviewed on a case-by-case basis, so different configurations may be needed. Someone unfamiliar with this area may think you can put an antenna anywhere on the pole, but you've got to be very careful to maintain the proper clearances. So different pole owners may have different requirements, necessitating different configurations for different areas. All the way over on the left, you see a typical configuration on a pole that carries secondary power. This one happens to be in New Jersey. You've got the antenna on top of the pole and the equipment down lower on. In the middle, there's a pole in Florida that's carrying primary power. We've got the antenna on top, but in that particular area, there's a requirement that all attachers place equipment other than the antenna off the pole. So you're going to have street furniture. Finally, you can see a streetlight configuration in Massachusetts where we can install all the components on the pole itself. The end result, broadband where you need it. DAS and small cell sites provide a viable solution to meet the smartphone and mobile computing needs in all types of communities for now and in the future.
Thank you, Noreen. My name is Stephen Garcia. I'm the Senior Manager for Land Use and External Affairs at Crown Castle for the West area. Today, I'd just like to spend a few minutes with you to share some of our experiences in the permitting DAS facilities in the public rights-of-way. Permitting for outdoor DAS in public rights-of-way, factors affecting development or deployment of broadband in residential areas. So just a few different takes here before I get into the slides. These would be privately owned or investor-owned utility poles. In this particular case, we're talking about streetlights. So the examples that I'm sharing with you today are focused on where we have existing verticality in the form of streetlights or poles similar to that. It's not going to include anything that required new poles. Permits for outdoor DAS. Essentially, the permit process for public rights-of-way across the United States has come down to three possibilities. Ministerial permits, sometimes known as by right, administrative permits that can come in a variety of forms, and conditional use permits. Between those three categories, we probably see maybe 5% of our applications being reviewed on a ministerial basis, maybe 20% administratively, and probably a bulk of them, 75%, handled through a conditional use permit process. Ministerial permits, jurisdictions permit DAS facilities in all residential zones and all zones throughout a community. Typically issued by the Department of Public Works. Durations are 1 day to 30 days. And application process and fees are low to moderate fees, and the application process is standardized. Public comments are typically not included in this review process, but that's a result of the fact that standardized requirements apply to all applicants. In the particular example on the right-hand side, you're taking a look at, you're seeing a multi-carrier facility, again, handled ministerially. That was handled within 30 days of our application. Again, this is a replacement pole in that particular community. Administrative permits, jurisdictions process the application administratively. A public process is included, and it's also subject to appeal. Issued by department manager or planning commission or design review boards. Duration 1 to 4 months. Application process is standardized, and we have moderate to higher fees. Public comments are included, and that can be before the application is approved and or after the application is approved. In the example on the right-hand side, you're looking at an administratively approved single tenant design, but that particular location was also approved for multiple tenants. And in this case as well, the pole was replaced. The original pole was 30, now it's 36. Conditional use permits, jurisdictions regulate the discretionary process. It's issued by planning commissions and or city council decisions. The duration can be 4 months to more than 1 year. The applications are higher fees and non-standardized processes. Public notice is included. In this particular example, you're looking at a streetlight replacement. Again, as we showed earlier in the ministerial permit process, that was a multi-tenant design handled ministerially. In this example here, you're looking at a conditional use permit process, and for the same type of application. One thing that DAS can offer is a standardized design, and I think it gives both sides the opportunity to decide and find better best practices to handle multi-tenant or single-tenant distributed antenna systems. Examples of DAS. We'll just go through a few more slides and share with you some of our experiences here. The photo on the left is a near view example of a public right-of-way installation with pole-mounted equipment. One of the concerns that we hear often is the bulk and size of the antennas, the bulk and size of equipment. There are a variety of options for us and the communities to consider. I think there's one for each community already available. It just takes some time to work on both sides to find what works best in that community. On the right-hand side, you have a distant view. You can see in between two existing light poles, we placed a new DAS facility. Again, a lot of the concern is height, bulk, and appearance in the public rights-of-way. And here you can see it blends in well with the surrounding rights-of-way facilities. A couple of examples of single tenant and multi-tenant designs. One of the things I'd like to point out here is the height. The original height of the proposed structure on the left, or existing structure, was 30 feet. Again, in this particular example, we've added the antenna to the top of that facility, and now it's 36 feet. The characteristics on the right-hand side are similar. The original structure height was 30. Now it's been improved to 35 feet and supports multiple tenants. Just a quick slide I think is important to share with you. A lot of the concern, again, is bulk, height, en masse. Here we have an example of a typical streetlight infrastructure facility that we replace in various communities across the United States. It's a 30-foot light pole with a 2-foot luminaire. So that puts you at a 32-foot height. The pole on the right side is a DAS light pole. And now with the extension of our antennas, we were at 39 feet. And if you go back one slide, you can take a look at that. 2 slides, excuse me. On the right-hand side, you see that fits in well with that infrastructure in that public right-of-way. So in conclusion, the variety of design options, including low-profile design features, makes DAS facilities highly compatible in public rights-of-way and residential settings. Thank you.
Thanks, Stephen. My name is Jim Seymour. I'm Senior Director in the Wireless CTO organization at Alcatel-Lucent, with responsibility for supporting product and standard strategy for all of Alcatel-Lucent's wireless solutions. And today I'm going to talk to you about small cell technology, and in particular, the portfolio and solutions that Alcatel-Lucent is working on to provide small cell technology. Get the slides. Thank you. So, in line with what we've heard from the previous speakers, our approach to small cell technologies is very much in line with providing the capacity where the users are. As mentioned, macro cells are not the most efficient way to do this, and our approach is to really come up with the small cell solutions that really provide the lowest total cost of ownership solutions to provide the capacity and coverage where it's needed. And what this means is that there really isn't one solution that fits all. As seen in the picture here, which is a typical urban moving into suburban area, you can see in some cases home cells will be needed in the more neighborhood types of areas where people are looking for improved coverage in the house. Small cell solution optimized for the home is what's needed there, but as you move towards office buildings, more enterprise solutions, in some cases DAS, to provide coverage in the buildings will be more optimal. In some cases, Wi-Fi solutions may suffice for coffee shops, restaurants. And then there's still other cases where metro solutions, meaning either open access indoor solutions or outdoor solutions to provide not only coverage coverage in places where the macro doesn't cover, but also improved capacity even where there is good macro coverage. And so when you look at this type of scenario, you can see that one solution is not going to be optimized for every one of these scenarios, and that a whole portfolio of small cell solutions is required to really provide the capacity and coverage where needed with the lowest total cost of ownership. So at Alcatel-Lucent, we have been developing a full suite of small cell solutions that's shown on this slide here, which have really approached the small cell space from 2 directions. From one direction on the left, we've focused on home cell solutions that are based on 3G, because for home cells, the important thing is providing voice coverage in the house, and the voice solutions today are supported by 3G. So that's why the focus has been on 3G for the home cell, where you can provide 4 to 8 users capacities with around 100 milliwatts up to 100 milliwatts of power to cover the house. As you move towards the enterprise types of solutions, you need to build that up in capacity to 8 to 64 users, higher power, around 250 milliwatts to cover the building. But both of these solutions for home and enterprise are based on much more flat IP technology, what's called the IUH architecture in 3G, where the controller functions have all been flattened down into the small cell nodes, so that you can have hundreds to thousands of these that are all supported through a gateway that basically hides the topology of the small cell network from the macro network and makes it look like a single controller to the rest of the network. So this enables us to really scale appropriately the small cell solutions for home and enterprise. And then as we move to other indoor open access types of technologies, we build up that enterprise cell solution to provide an indoor small cell solution, a little more power with MIMO technology, and further expand the number of users. And then building that, we ruggedize that solution for outdoor to provide even higher power, up to around 2 kilometers of coverage for where you have outdoor hotspots. Okay, and these types of solutions can be provided in either the dedicated carrier with 3G or in the same carrier as the macro. We have interference management techniques that we've developed in order to make that possible. And even though we started with 3G in these technologies, as we move at least towards the enterprise and indoor and outdoor metro cells, we see the need for Wi-Fi in these solutions as well as 4G LTE. Because if you're going to be deploying these small cells, you really want to leverage all the spectrum that's available there, both licensed and unlicensed, to provide the maximum amount of capacity in that area where you deploy the small cell. So all of those solutions there from enterprise up through outdoor will support 3G, 4G, as well as Wi-Fi. Now, from the other end, from the deployment of macro LTE, we've been building down those solutions to provide metro cell solutions for LTE, particularly focused at outdoor capacity, offload of the macro. Because, with, as mentioned, the wireless data explosion, in particular, indoor data usage, there's the need for basically offloading all of that indoor coverage with metro types of solutions for LTE, so that the macro can mainly cover the outdoor users. And these solutions, even though I show one solution here where we have a metro cell of around 2 by 5 watts to provide large coverage, but one of the things we've really been focused on is our light radio solutions in this space, which are based on the cube technology shown in the picture here on the top right, that copper-looking cube. The cube is basically an innovation from Bell Labs that has integrated the antenna and RRH technologies all into a single cube, where at around the 2 gigahertz frequency, we can support in a 2.5 inch per side cube all of that technology with up to around 2 watts of power. And so this is in line with some of the discussion earlier about trying to make these small cell solutions invisible. Now, this single cube we could connect to fiber CPRI backhaul, and this can be providing coverage, in a building or in an isolated location with just a single cube of that size. But even more importantly, we can use this cube to build even more innovative small cell solutions. For instance, we've taken this cube and put a couple of them onto what we call a cube dock that can then be CPRI backhauled to centralized baseband assets. And this provides an optimal solution for things like stadiums, where you can provide very focused coverage. It's a directive antenna solution where you can provide around 65-degree coverage, both horizontally and vertically, to focus it on sections of the stadium. And then through fiber backhaul, support the baseband technologies with load sharing across these various cube docks that can be placed throughout the stadium. And the load sharing aspects is key because, for certain events, say you have a concert in the stadium, half of the stadium may not be used, but you'd want to still leverage all of the baseband assets that are available there for where the people are. In addition, we've built up from these cubes all-in-one small cell solutions where the baseband is integrated with the cubes. And we've developed a family of technologies called small cell metro cell family that are very in line with the pole mounting discussions we had earlier, where we have 2 modules, one module that supports the backhaul and the power that can be basically nailed up onto the pole once, and then the RF and filtering and baseband module can be snapped onto that, so that over time, if it needs to be replaced, it can be very simply replaced by snapping the RF and filtering module off and putting in a new one. or as technology evolves over time, and 3GPP release 12, 13 in the future will probably require new technologies there, we can upgrade to the latest and greatest technologies. And then finally, we're also working on more advanced small cell technologies that use an array of 2x4 cubes, where we can actually do beamforming, create 3 beams in the horizontal direction, and do MIMO in the vertical direction. And this can be used to be placed on like one side of a building and focused on buildings on the other side of the street, and focus the beams into like the windows of the buildings. Instead of having power blasting on concrete and bouncing off and not being able to penetrate the building, we can focus beams to really get all of that energy into the buildings. And this provides a very nice solution for outdoor to indoor coverage, where some of the other small cell solutions are not possible. So as you can see, it's really a full suite of small cell solutions that are needed in order to provide the lowest total cost of ownership solutions for coverage and capacity. So just in summary, again, our focus is on providing capacity where it's needed with the lowest total cost of ownership. By providing these solutions, we get the most amount of capacity and the most reuse of the spectrum that's available out there. By putting the small cells where the users are, you get a much better user experience. Okay, users are getting much greater signal-to-noise ratios and higher throughputs when they're close to these small cells. Very flexible deployments. As we shrink the size of these small cells, it makes it much easier to put them on billboards and light poles and so forth. And you'll be seeing these solutions throughout this year introduced with a good time to market. Thank you.
Good morning. My name is Alex Gamoda. I'm a vice president with American Tower, focused on DAS real estate nationally. Before I start my presentation, though, I just want to echo what Alan said at the very beginning, to thank the FCC and NTOA for putting together this kind of day. As Chiefs Kaplan and Gillette mentioned at the beginning, the chairman's goal of expanding the reach of mobile broadband is very important, and to have folks like ourselves and then later with the other panels talk about, in some respects, the future is now in some communities and with some technologies. But as Noreen talked about the successes, and Stephen talked about the successes, and even with Jim, kind of the neat technology infrastructure that's being developed to support that. While I think there's a lot of lessons to be learned from those successes, I think it also highlights some of the challenges that also still exist, and hopefully we can all learn from that. What I wanted to do in the next 10 minutes was to really focus in from a business perspective on a few sort of key DAS business concepts. I think we talked a lot about small cell technologies, and I think that'll echo within this, because at the end of the day, whether it's a DAS, whether it's a traditional solution, which we've talked about, or if it's one of the small cell technology solutions, there's an antenna that has to go somewhere. There's a control box that has to go somewhere. There needs to be power. There needs to be telco connectivity to help those devices operate. And so whatever the solution may be called, the challenges, the successes that we've had are all sort of wrapped around business sort of drivers. So, Jim, I wish I had borrowed your slide. This isn't quite as colorful, but what I thought I'd do is just to step back and, from a big picture perspective, today, if you looked at the landscape, there are many ways of providing broadband solutions. You could build a new tower. You could co-locate on an existing tower. You could co-locate on a rooftop. And those are all things that, if you look at just the sheer numbers of installations, we're probably talking in the hundreds of thousands, and I'm sure someone here has a better exact figure than that, but that's the magnitude of what we're talking about as far as actual in practice. About 10 years ago, you started seeing more and more indoor DAS solutions happening. American Tower is one of the pioneers getting into that business back in 2003. And then in the last 5 to 7 years, Noreen with NextG, one of the leaders in outdoor DAS, and others, including American Tower, you started seeing outdoor DAS solutions happening. And as I think some of the other speakers said, you see DAS happening not just where there isn't coverage, but also where there is coverage and augmenting the capacity, especially on the indoor side and even more so on the outdoor side. And as Noreen said, it doesn't matter whether it's a high-end neighborhood or a low-income neighborhood or a college campus or even downtown Main Street. As we'll hear later, an example of that on one of the panels, outdoor DAS is one of those solutions. But I think it's important to remember, while there's hundreds of thousands of macro solutions out there today, conversely, on the outdoor and indoor side, we're probably talking about tens of thousands, although I'm sure that number will increase as we try to support the broadband explosion that we've been hearing about. So I guess one of the questions maybe you're thinking is, why isn't DAS everywhere? And I mentioned that there's really certain business drivers that a wireless carrier would be thinking about before they make an investment for a DAS. You can see on the slide here that we think that the DAS sweet spot, whether it's for indoor DAS or outdoor DAS, is right there in the middle. First and foremost, data, the data usage. For carriers to justify spending the money that's required for a small cell architecture like a DAS, it's really because they believe that there's a lot of data traffic there that they want to capture. Second is it's because you don't have a traditional siting opportunity. There isn't a tower you can co-locate on. There isn't land you could build a new tower. There isn't a rooftop you could co-locate on. So having the lack of a traditional siting opportunity also helps drive towards a DAS. And last but not least is that you have to have suitable DAS assets that are available. Not to say that you can't have a DAS without a suitable asset available. You're working in the right-of-way. You're attaching to utility poles or street lights or stop signs, as was mentioned. But that definitely helps drive into that sweet spot right there in the middle. At the end of the day, though, it's all driven by the overall DAS and traditional siting economics and time frames. Because a carrier is all about, or a wireless service provider is all about trying to serve its customers, and they want to do so in the most cost-effective, predictable, and time-effective way. So as mentioned, DAS is out there. It's broadband. Today and this afternoon, you're going to hear some specific panels talking about some phenomenal examples of where DAS is providing service and coverage and quality of life, mission critical in some cases, for people in communities, in convention centers, at universities, and even in hospitals. Again, going back to the Venn diagram, you can see why the places I just highlighted could be of interest. The data usage, the lack of traditional siting opportunity, and that DAS assets are available. I'm from Boston, those who know me, and I wouldn't be right to not take advantage of pointing out Suffolk University is in Boston, a great, fine institution. The Patriots, some of you may have heard of them or aren't too far away. Suffolk University wants to have great coverage and capacity for its students, its faculty, its visitors. LA Children's Hospital, which we'll hear more about later today on a panel, I'm sure they have a similar story to tell about the patient service as well as doctor and operational needs. Last but not least is Charlotte, North Carolina. Again, that'll be on a panel. And I think it's phenomenal that a city like Charlotte really embraced this sort of solution as a way of really demonstrating its commitment to being a first-class city. And then last but not least is the Kansas City Convention Center, which, again, going back to the Venn diagram, you could understand why a facility like that would be of interest for having a DAS. So in summary, there's a number of key success drivers for wireless broadband. And I think this echoes some of the themes that we've already heard from the other panelists. It's coverage and capacity where you need it. It's viable economics and timeframes. It's the full range of solutions. And it's best-in-class service. And really, at the end of the day, you know, and I understand that, and my company understands that very well. We're a carrier's carrier. We provide service to the wireless providers who ultimately have retail customers. They want the retail customers not to know that there's anything different with this network. It's seamless. The experience has to be as good as any other solution that's out there. Otherwise, it's not really a viable solution. On the economics, minimize the gotchas. Unknown unknowns and costs and project deployments, whatever business you're in, you know, is a killer. Standardize consistent financial arrangements. The more we can standardize the approaches, the arrangements, the faster these sorts of things will happen. Expedited use of existing infrastructure wherever available is also key, because it goes back to the time to market as well as even the costs. Last but not least is the time frames. You want to work with partners who provide accelerated, however realistic time frames. Because again, I think we've all maybe had at home or elsewhere a contractor who promised the moon, and then you're left in the a predicament of not having what you need done when you need it, and there's cost overruns. And finally, and I think hopefully this resonates with this panel and the others in the room who work with the asset owner, whether it's a municipality dealing with the right-of-way or streetlights, whether it's utilities with the utility poles, or it's the venue owners, the facility owners. What DAS is, or any sort of small cell solution, or any sort of telecom solution, it's a long-term relationship. Because once we have service there, the retail customers demand that that service continues in that location, uninterrupted. So to summarize, it's predictability. We need to develop, and what we've seen is that where things are predictable, solutions are more attractive. Cost effectiveness, repeatability, and viability in the short as well as the long term. Thank you very much. I know that there aren't any questions for the panel during our slot, but some great resources is obviously the FCC on their website. The PCI DAS Forum also has a great website with FAQs, and then I'm sure on behalf of the other panelists, if you wanted to reach out to us directly, feel free through our companies. Thank you very much.
Yes, I want to say thank you to the panelists once again for that informative session. I'm sure that everybody got a lot out of that. And, you know, we are the Federal Communications Commission, but we do have technical issues just like everybody else out there, which the remote audience can attest to this morning. So we are working to get the live feed fixed, and we are working to get the presentations posted up to the event page as soon as possible so that you can follow along as you're listening in remotely. We're going to take a short break now, about 10 or 15 minutes. It's about 10 of 11, so if we could come back about 11:05, and if we can have the panelists for panel number 2 come forward, and we'll get everything situated for the next panel. So we are working to correct the technical issues we're having with our web stream, and hopefully it's corrected. And for those of you watching remotely, if you could just refresh your screen. We've changed servers, so hopefully you'll be able to see the whole shebang now. So, and again, I want to remind you that if you want to submit questions remotely, you can submit your questions to the email address livequestions@fcc.gov. Please include, if you want to address a specific panelist, include that, include your name and what organization you are affiliated with along with your question. And for those here, we have several FCC staff walking around. They have note cards and pens if you don't already have them, and just raise your hand up and somebody will come collect your question from you. As time constraints and volume of questions received allow, at the end of all the presentations, we'll be able to do some questions and answers. So now the second panel is ready to start. We have two moderators for our panel. The first moderator is Dan Abeda. Dan is an Assistant Chief in the Spectrum and Competition Policy Division in the Wireless Telecommunications Bureau here at the FCC. And his co-moderator is Don Johnson, who is an attorney in the same division with Dan.
Good morning, everyone. We're happy to have such a large audience with us today. Our second panel today is going to be looking at DAS and small cell technology in public spaces. As Cecilia indicated, you'll have an opportunity to ask questions. On the cards that you submit, please indicate the panelist that you would like the question addressed to and the small cell DAS use that you want addressed, whether it's in hospitals or whatever the area that you want addressed. Speaking of questions, we have received our first question, and I thought we would take it up immediately. The question is, could you address the difference between DAS and small cells? And Seth has offered to answer this question. Just as a little bit of a background, Seth, who is our first panelist, Seth Bueckley, is the president of Solid Technologies USA, a leading provider of DAS and optical transmission solutions. Seth will be discussing DAS in buildings and how they comply with new model fire codes. But first, Seth will be answering the first question.
Sure, thank you. Well, it is a bit confusing in this time in our industry. That's part of what you have when you have emerging technologies, is there's kind of a battle for naming, there's a battle for standardization, and DAS in itself struggles in that when you say the word DAS, some people think outdoor DAS, some people think in-building DAS. They're actually very different markets, but they've fallen under the DAS bucket. Essentially, the question was, what's the difference between DAS and small cell? I believe that the phrase that's going to emerge, it's my opinion, is that outdoor DAS will more and more become known as small cell, and that DAS, the phrase DAS, will probably default back to being indoor. Small cell essentially is the method by which you get tower sites closer to the people. Outdoor DAS is essentially the method by which you get tower sites closer to the people. It's no secret, I'm not in the tower business, so I can say this, that towers aren't that pretty to look at. Yet, the way that you make smartphones work better is you get the transmitters closer to the devices. And so small cell is essentially the effort of moving those transmitters closer to the people. And there's all sorts of architectures to do that. And the method is to make all of those small cells work together seamlessly so it feels like one network. And so in our thinking today, as we describe our industry, we talk about tower sites or the macro network, we talk about small cell, and then we talk about the indoor DAS environment. That's how we are defining it, but everybody gets to pick how they define their own business.
All right, thanks.
You bet. So I'm going to briefly move into my presentation this morning, and that is how DAS solves some very practical problems. I won't take the time to walk through the 101 of why DAS or how DAS, because the panelists before us did that very effectively. But I do want to point out some problems. And today I'm going to talk to you about carpooling. I want that thought to resonate in your mind, and we're going to get back to why. So, as you know, radio frequencies don't do very well penetrating large buildings. The problems that reality create are many. First and foremost, in a connected world, we feel very disconnected when our smartphone doesn't work. When you're at the hospital and you're having a personal crisis, that's exactly when you want your smartphone to work so that you can keep your family informed of what's going on. When you're in transit and somebody's expecting to meet you there, it's exactly when you'd like your smartphone to work. When there's no radio signal, we are disconnected in a very connected world. Second, the public safety community has, for many, many years, gone without basic radio coverage required for them to do their job, which is to protect the public. And there's been some activity around that I will focus on in my remarks. During an emergency event, it's critical that the first responders' radio systems work. And many of the places where the public congregates are considered high-value targets from a terrorism perspective. And that framework creates the impetus to improve public safety radio coverage. And the third, which is actually the economic driver of this entire discussion. The earlier panels which talked about outdoor DAS were driven by the carrier's willingness to pay rent to be on those outdoor DAS systems. The number of DAS systems that are being deployed is going up exponentially. We were at a meeting recently in the San Francisco Bay Area, and one carrier said they anticipated deploying more DAS systems than cell sites in the coming year. So degraded service is really lost revenue for carriers, particularly as we've moved away from bucket plans back to data usage plans. And so the data networks are the carrier networks are being crushed by the demand for data. Over 50% of the new devices activated with some of the fourth quarter reports were smartphones. So this problem is not going away, and frankly, carriers cannot charge for data they cannot deliver. And the way to solve all of these problems is DAS. So the stakeholders in this topic, you have authorities having jurisdiction, which would be a municipality or state who chooses to adopt a code. And when I talk about the code, what we're talking about is national codes which have to be adopted and enforced at the local level. And more in jurisdictions all across the country, the codes are being embraced and enforced to give the public safety community what they've been asking for so many years. At the same time, you have wireless service providers who are approaching venue owners saying, I will now respond to your request for service, or I will now target your venue so that I can offload some of my macro traffic using an indoor type solution. So the wireless providers are driving DAS deployment. And then the last one, the poor guy caught in the middle, is a building owner. The building owner is being approached by a wireless service provider who'd like to provide DAS, is being approached by local municipalities saying, when you do deploy your new DAS, or when you go to open your new building, you must demonstrate reliable public safety radio. And the building owners are getting a little bit more proactive, and they're saying, okay, I want to make sure that my system provides cellular coverage, two-way radio coverage, and public safety radio service. So some basic concerns, they sound basic, are around the topic of who's ultimately responsible to provide this DAS. That could range anywhere from the building owner, it could be the operator, it could be a third party. It's not going to be the public safety agencies for the obvious reason that they don't have money for these kind of things. They have money for other things, they don't have money for these kind of things. Who should pay for it? Can't be the guy who doesn't have money. So the building owner often hasn't budgeted for it. If it's a new building, they may have a budget for a DAS. But in an existing building, essentially what they're faced with is an unfunded mandate to provide public safety coverage. And then along comes a cellular provider saying, I would like to provide cellular coverage, which creates an interesting debate. And so our industry is wrestling with these topics. Who should pay for the DAS? Who should own the DAS? Who should be responsible to manage it? Now, managing a DAS isn't that complex, but when public safety gets involved, when license frequency is involved, there's a lot of opinions. And so I believe in the same way, if you look at the cellular industry, in the early days, people didn't want to tell you where their cell sites were going to be located, as if you could hide a tower, right? Then eventually the industry figured out how to share towers, and then eventually they figured out that they preferred to share towers. The same thing has happened with DAS. At first, each cellular provider wanted to provide their own DAS, And then the industry and the technology from companies like ours and others has evolved to allow it to be easily shared. And now we're going to take it one step further, and that is the public safety community should also be included in these DAS systems. And we're wrestling with the same kind of issues we've evolved through previous to this. So who should manage the DAS? When you have signal source that's delivering your public safety frequencies, the public safety officials feel very strongly that it needs to be somebody that is certified to manage their frequencies to their satisfaction. And then what services should be provided on the DAS? Should we provide only cellular? Should we provide two-way radio if the building owner happens to have some two-way radio licenses? Should we allow public safety to coexist? These are the issues that we are wrestling with. And so what we've proposed and what we're announcing is a coalition, a shared DAS coalition, to begin to work together to tackle these issues. And we're calling on the local municipalities. We're calling on the APCO officials with the public safety community. We're hoping that the commission itself will weigh in on this topic. And the wireless carriers are a huge stakeholder that needs to come to the table and wrestle through these things. Essentially, back to my idea of carpooling. The public safety community shouldn't be considered a hitchhiker. They should be considered a carpooler. We're all going to the same destination. Clearly, these are known entities. We need to be talking to each other about ways we can leverage the infrastructure to accomplish more. And so we're hoping that we can move from an environment where building owners feel like they have an unfunded mandate to provide public safety. And perhaps we can come up with some policy that suggests when a new system is being built, the right thing to do is to share that system for the benefit of all. And clearly, each stakeholder has technical issues they need to be satisfied with. And we also have some other issues in our nascent industry, and that we don't have real certification bodies offering real certification that's recognized by the various stakeholders. And so we as a coalition need to wrestle some of these issues down to the ground and get them solved. But the first topic of all is, we need to begin to communicate together. And so that's why we're calling on the coalition to do this. We need to figure out the cost sharing models, and then we need to figure out the certification piece, which gives everybody a comfort level that the right things are being addressed. So thank you very much.
Thank you, Seth. David Tuttle is our second panelist. He's the Director of Public Safety Solutions at Cellular Specialties. Prior to joining his company, David served as the Director of Emergency Services in Queen Anne's County. David will be discussing public safety solutions and how public safety entities and commercial carriers are working together on in-building systems. David.
Thank you. There we go. So, I think I bring a little bit of a unique perspective to the topic here. In addition to my background that's identified there, I had an opportunity to also work with Nextel in their public sector strategy group, tackling these types of issues, as well as Sprint and their in-building division after the Sprint-Nextel merger. And then today I work for an integrator that actually supports those businesses and a lot of the manufacturers and equipment vendors that are here today. So what we know is that in the public safety world, there's definitely an in-building demand for coverage that the entities that be are struggling with. And it's really, as Seth mentioned, it's an unfunded mandate. So how do we get that funded is really the difficult question. What we do know, and from the industry where I come from today, which is the integrator model, is that many of those targeted buildings already have either a carrier-funded, a customer-funded, or a third-party funded distributed antenna system. And it's generally, we see this twofold. Either it's an afterthought to add public safety to that, so the carpool type scenario that Seth described, or we see just the opposite. So we see new building where codes are enforced, and in the specs for these new building or these new construction projects, there is a requirement for public safety, but then not a requirement for cellular. And I'll touch base on this in just a minute, but there's a tremendous public safety value to having that communication, whether it be for the public safety entities, i.e. their two-way radio system, or the end user, the public, the consumer, that's dependent upon their device today more so than ever for emergency calls and situations to actually notify the responding agencies that there's actually an event that's taken place. With that, public safety has driven through two different entities, the IFC and the NFPA, really led the charge to develop standards or guidelines with regard to fire codes as it relates to public safety communications. There was previous communication language clearly in those codes, but it really revolved around the wireline firefighter telephone systems. So we see this in hallways of high-rise buildings where you plug it on one floor to a fire command center. And it's actually become quite aggressive in the way that they're addressing this, because that particular code with the wireline plug-in handset system becomes ineffective based upon the way that the firefighters tackle their emergencies today. The autonomy of having their radio and being able to communicate throughout the building is not only a safety feature, but it allows them to be much more efficient. The other thing that it does is that it allows public safety beyond fire. So the emergency medical services, it's impractical for the ambulance to plug into a firefighter phone to communicate with someone on a 12th floor of a building, to coordinate getting a patient out of a building, or alternatively the police departments. So the two that I'm speaking of, and I just mentioned the International Fire Code, which is really developed by the ICC and the NFPA. And the issues with the codes, it's great that they're there, but what has to happen is they're just a guideline. The entities that need to adopt these are the local jurisdictions, and some jurisdictions are very aggressive in adopting these, and some are not. And I would argue that the reason that they're not adopting these is because there's cost issues, right? So it's like with any other building code change. If there's costs, there's essentially a lobby to push back against that. And then the last thing that I want to touch base on is the public's safety and cellular consideration. So a little bit different twist than just simply the firefighter or the police officer's radio working. But we really need to consider that, and the numbers vary, but the rough demographics of the calls are roughly 70% of telephone calls, cellular, are originated within a building. And then roughly 70% of 911 calls are received by mobile devices. So we could take the markets and the demographics, and we can look at that particular funnel, if you will, and it's gonna vary, versus Manhattan versus a much more rural area. But the argument is to be made that the public is dependent on using their wireless devices for notifying emergency services, specifically in public venues. And then the other thing that we don't consider is the discrete areas, the parking garages, underground areas, tunnels, all of which really are areas that are designed for in-building distributed antenna systems. So, thank you.
Thank you, David. Marty Miller is our next panelist. He's the Chief Technology Officer of Children's Hospital, Los Angeles. Marty is responsible for leading the hospital's technology strategy development. Marty will discuss with us how hospitals are adapting DAS and small cell solutions to meet broadband healthcare demands.
Good morning.
Good morning.
Children's Hospital Los Angeles is a 317-bed academic pediatric facility. It's nationally recognized for its excellence and its research, and in many ways it is representative of many hospitals here in the United States. Our hospital has 1.2 million square feet of wireless coverage through a DAS, where multiple technologies are being deployed. You'll probably remember the times when you would go into the hospitals in the past and you'd see those signs that said no cell phone usage here, or there'd be waiting areas about 10 feet in diameter that said you can use your cell phone inside of this ring here on the floor. Those days are gone. When people come to hospitals now, they expect to be able to use their cell phones, their smartphones, throughout the entire facility. Hospitals are embracing the enterprise use of wireless for productivity reasons. You've likely seen wireless computers on wheels being wheeled from room to room as they do documentation. And then finally, medical grade wireless devices are increasing in hospitals, and they demand an assurance level that none of these other classes of service require. And small cell architecture allows for each of these 3 grades of service that previously mentioned, with the appropriate level of assurance for each of them. This is a busy slide, but it tells a very simple story. That being that hospitals today are now likely the most complex and densely deployed wireless environment where critical care is being delivered. I'll give you some statistics about our hospital, and I believe they're representative of what you will find across most. I mentioned earlier those wireless clinical documentation devices that get wheeled around from room to room. Between those and laptops, enterprise laptops in our environment, there are about 700 of those devices. We have 1,600 smartphones that are enterprise, belong to either a doctor, a nurse, administrative staff, or researchers that connect to our network every day. We have between 3,500 and 5,000 cell phones from patients and visitors and guests who peruse our halls every day, and 14,000 medical devices that will all be wireless within the next 5 years. You can see that the paradigm inside of a hospital is different from what you would see at a sales office, where individuals may want to connect through standard wireless protocol. No, our assurance levels from ICUs into med-surg units, and then eventually when you put a wireless monitoring device on an individual and send them home and want to collect that data, we have a very complex environment that needs to have assurance delivered as it pertains to medical care. Additionally, when the FDA approves a device, typically they assume that the transport, whether it's wired or wireless, is going to work flawlessly. They make that assumption. So then how can assurance be achieved as it pertains to a wireless environment? The West Wireless Health Institute has formed a council of leaders, CIOs, CTOs, CMIOs, CFOs in hospitals. They are a not-for-profit group leading an initiative to create a reference architecture that is open and enables ubiquitous healthcare, whether it's in the hospital all the way through monitoring at home. And small cell architecture plays a key role in this architecture. Specifically, as I referred earlier to having 14,000 biomedical devices in our institution, medical grade wireless and the associated assurance that goes with that requires a technology that small cell architecture can address. And so you'll notice on the slides that this is really the sweet spot where we think small cell architecture allows us to get that assurance level and ubiquity. The medical grade wireless utility, again, this is somewhat of a busy slide, but the red bubble indicates this clinical data network, the one where we're seeing explosive growth in devices, where we need assurance levels that go beyond just a consumer using a smart device or a patient or their family using a smart device inside of a hospital. Hospitals, as I mentioned earlier, have become the most complex and densely deployed wireless environment. They're delivering life-critical information, point of care, And they are ideal for small cell architecture solutions integrated into this medical grade wireless utility. Hospitals are ready to engage with cellular carriers to address the enterprise and medical requirements for wireless. Hospitals do not want to be treated as a collection of 1,700 consumer plans. They want to be addressed as an enterprise, realizing the critical nature of some of the things that happen inside of those walls. Children's Hospital Los Angeles is ready to be a beta site for that small cell architecture, and it's our belief that an organization that is a nonprofit medical research organization could be a focal point for the use of small cell technology in hospitals. Thank you.
Thank you, Marty. Our next two panelists will discuss the use of DAS on campuses. Mary McLaughlin presently works for the University of Michigan, directing its strategic effort to improve wireless service throughout the campus and the hospital. David Fasshauer is the Director of Implementation and Engineering with Extenet. Dave has nearly 30 years of experience in telecommunications engineering, focusing on fiber optic networks. Dave will discuss the dynamic and diverse DAS system used by the University of Michigan. We'll start with Mary.
I'm going to describe the situation at the University of Michigan, but I will say that what I'm going to talk about is consistent for many universities around the country. And first of all, cell phones are nearly ubiquitous. Slides are coming up. There we go. Cell phones are nearly ubiquitous for faculty, staff, students, and visitors. They're used, of course, for personal and work communications, but also increasingly for teaching and learning. Cellular is replacing landlines in some campuses and many campuses, and it's becoming very key to mobility strategies. So that is a very important concept. Cell phones are also, as you've heard from the other panelists, very important to safety and security. And our buildings are often occupied for long hours beyond the typical 9 to 5 business day. And again, the statistics out there that were pointed out before, 70% of cellular calls and 80% of data connections originate from indoors. So the key point on this slide is that indoor cellular is really critical to our operations and our community. The problem, a very high percentage of our building space has poor cell phone reception. We have big buildings, we have historical buildings, we have laboratories. We wanted to get more than just anecdotal information on that, so we did test about 200 buildings and roughly 25 million square feet on the University of Michigan campus. And we found that about half our space did need some augmentation. The problem, of course, is worse in new buildings, or is bad in new buildings that have a lot of glass, because the thermal shielded glass blocks RF. We also have additional capacity problems, major capacity problems in our sports venues, U of M Stadium being one, of course, on game days. So the connectivity in the stadium, if you were just to walk there today, is fine, but on a game day, the capacity isn't there. Oops, what slide? I think we're missing a slide there. Well, there's the slide that's missing, and I'll send it out, I'll get it to you, Don, is that the bottom line is we own the buildings, but we don't own the spectrum. We need the wireless providers' full support to do anything inside our buildings. We need their dedicated engineering attention, we need their financial commitment, and this is expensive. The financial commitment is a lot easier if you're a large public venue, if you're an airport or a mall. It's also easier if you're a private venue that buys handsets. But the university is not either of those, except on game days, of course. The stadium is, of course, a very large public venue. So we have a challenge. And again, the key point on the slide that I'll include later is that the financial commitment is difficult for the wireless service providers. It's challenging because, again, we're not a big public venue and we don't buy handsets for faculty, staff, and students. So, these slides are a little out of order here. That's the problem. All right. So the progress that we've made at U of M is we issued an RFP and we hired a third-party neutral host service provider, that's Extenet Systems. And what Extenet does is they build a multi-vendor network and they sell the service to wireless service providers. They need also the wireless service provider's engineering support and their financial commitment to get anything done. At U of M, our first priority was the U of M Stadium for this year's opening game and the new Mott Children and Women's Hospital. And so that was our first two priorities, although the overall project was to, let me see if I can back up here. This is the slide. These were our main goals. Our project goals were to expeditiously, and I underline expeditiously, we wanted to have high-quality voice and data cell service from multiple carriers. We wanted the service inside buildings to be remediated for 70% of the cellular marketplace, for carriers that represent about 70% of the marketplace. Again, we can't dictate what phones come into the buildings. That was a target we had. We wanted the service remediated in all university-owned buildings over 10,000 square feet. We picked that number because under 10,000 square feet, generally they're met by the outside macro network. I will say that the macro network in Ann Arbor is typically sufficient. We wanted the service fixed inside our buildings in the Ann Arbor campus, U of M hospitals, Flint, and the Dearborn campuses. And key, we wanted the costs absorbed by the carriers. We didn't want to invest capital dollars in an asset we weren't going to own, and we did feel that the carriers should fix the service, their service inside our buildings. So those were our goals. The progress, again, we have hired Extenet Systems to build our DAS to meet those project goals that I just mentioned, and Dave can talk a little bit about the technical architecture.
Thanks, Mary. Again, good morning to everybody, and thank you for allowing us to be here to speak in front of you. Again, my name is Dave Fassauer. I'm with Extenet Systems. And Extenet Systems, as Mary says, was awarded the task of constructing a DAS network at the University of Michigan campus-wide. And again, this is a shared open network that will be available to all carriers and all technologies. The scope of the project, basically, 200-plus buildings, 64 outdoor nodes planned, multiple sports venues, and of course the campus is made up across three different cities, and we'll talk a little bit more about the sports venues a little bit later. Go ahead, Mary.
And the technical architecture was 64 outdoor DAS nodes, and we hoped that those would serve the smaller buildings, and the indoor nodes we assumed would be needed in the buildings that are over 200,000 square feet.
Working at the university, I found out early on it's a very complex environment. Every single building has their own facility manager. You have to get approvals from every single building manager before you can do anything. There's multiple committees, aesthetic committees, that you have to sit in front of. And I learned early on that it was going to be a very complex build. The U of M also has their own local codes and processes that you have to follow. They're exempt from a lot of the national codes. So before you do anything, you need to make sure you engage those folks and learn what the local codes and processes are. And then back to the slide that's on the screen, aesthetics was one of the biggest concerns of the university. And these are two buildings that we're going to be installing rooftop nodes and antennas on. And as you can see in the picture at the top, the antennas are going to be mounted in such a way that they'll blend into the color of the rooftop behind it. So if we've done our job properly from the ground, you won't even be able to see those antennas. And of course, the other building is a brick building, and the antennas, again, will be painted to match the facade of the building. So again, from the street, it's not that you won't see it, it's just that it'll blend in. So again, if you can't see the antennas from the ground, we've done our job. Go ahead.
And again, the infrastructure is complex, it's expensive. I'm not going to go into the detail on this slide. These are just the snapshots of the head-end space. Alan Dixon talked about that a little bit earlier. So again, complex, expensive. We have a trial set up in 5 buildings testing a new antenna technology that uses the HVAC supply ducts to carry the cellular signal. That trial has 4 carriers but 9 different technologies. Again, expensive and complex. Michigan Stadium, again, the stadium was the first build, and Dave, if you want to just run through that.
So our first challenge when we walked into the University of Michigan was they said we have to build Michigan Stadium, and it has to be done by the first game, which I believe was September 3rd, which left us 45 to 60 days to build the 3rd largest stadium in the world. We did it. We actually completed the build in 45 days, about 2 weeks short of the first game. This was basically built for capacity on game days. If there's no game going on, you can use your cell phone all day long, send data, whatever you need to do. But on game day, talked to a number of people and students, and many people told me that they just leave their cell phones at home when they go to the game because they're virtually useless to them. One of the big, as I said earlier, concerns at the stadium was aesthetics. Everybody wants us to provide coverage, but nobody wants to see what's providing their coverage. They don't want to see the antennas and the equipment. So we came up with some pretty creative ways to do that. We installed antennas over the portal entrances of the stadium, covered it up with a shroud that it basically blended in with the architecture. The equipment was mounted underneath the stands, out of sight and out of mind. Again, we had to adhere to local codes. Inspections from University of Michigan inspectors. And back to the aesthetics, again, this is basically it's a coax cable network, which really doesn't have to be in conduit. We chose to install the 4,500 plus feet of coax cables inside conduits because everything in and around the stadium was built in conduit, so we wanted to blend in with the environment, so we put it all into conduit. It was an expensive proposition, but it blended in and it came out very well. Along with providing coverage inside the stadium, we had to provide coverage outside the stadium. University of Michigan has a history of tailgating very early in the morning before games start and into the evening, and there's just as many, if not more, people outside tailgating. So we also constructed to date 13 outdoor nodes in and around the stadium to provide coverage as well to the tailgaters.
And I know we're kind of getting down on time, so again, the point is this is complex. It's big, 135 antennas, 60,000 feet of coax. And I'll just jump to the Children and Women's Hospital, the second installation we have. It's a brand new hospital. We call it the new extraordinary building where we do the same extraordinary medicine. The problem there is lots of shielded glass, a beautiful facility, but it's thermal glass, so the RF doesn't penetrate. It's very, very challenging indoors. It's 1 million square feet. Again, a very complex and very expensive installation. The amount of cabling installed was 27 miles of cabling. So again, I probably can't say that enough. So the main point here is that the university doesn't control the pace. We would love to have all of our 200 buildings fixed and our hospitals fixed in 18 months, in a year. That's not going to happen. It's much slower than the university wants, and it's really all about what the wireless carriers can provide funding for. And as an example, I have some examples of where the carriers are now. In this slide, I won't go through those, but the point is the carriers all have different competitive positions. They have different methods and procedures. They have different deployment strategies, and all those variables control the pace at which they're willing to deploy inside our buildings. one of the questions I have and I've been talking to people about, and I think we need to think about, is what is our infrastructure model? It's not like water, electricity, the internet, Plano telephone service, Centrex, where the building owner constructs, or in the case of IW for regular POTS, extends the service inside the building, and the building owner manages that indoor infrastructure, and we connect to the service provider at the building demarc. With cellular, you know, the demarc is defined, but it more practically appears like the demarc is the handset, and the service providers don't consistently provide their service all the way to the handset, and the building owners can't touch the spectrum inside the buildings and fix it ourselves. So again, we don't control the pace. Extenet doesn't control the pace. We try to do whatever we can to encourage the service providers to expedite the pace. So last slide. The future really isn't clear relative to in-building cellular in large, complex private venues like the university. So where are we? It's clear that we can't wait 5 years for our buildings and 3.5 million square feet of hospitals to be fixed. So what are we doing? We're working on new technology options that might help reduce expense. I mentioned an antenna technology that would get rid of a large part of 27 miles of cabling, hopefully. I would love to talk to Alcatel-Lucent about their Cube technology. And I will say that universities tend to be a very good venue for market trials of technologies. We are open-minded, we are progressive, we're early adopters of new technology, network technology, traditionally and continually. So we frequently will put resources into potential new solutions. We're also looking forward to LTE. Is an all TCP/IP infrastructure going to be more cost-effective, going to help us implement the technology faster? We're talking about our colleagues in other universities about strategy, and we're also interested in what the commission and what industry might advise us in terms of next steps. Thank you.
Thank you, Mary and Dave. We now turn to how DAS and small cell solutions can provide economic value and broadband capacity in businesses and historic districts. David Schneider is Director of Municipal Relations with Extenet. David has 25 years of experience in land development and zoning and is a former municipal planner. David will discuss deploying DAS in the historic district of Franklin, Michigan.
Thank you. Well, I was given the task of sitting behind U of M so that they could have a little extra time, and I have to rush through some slides, and hopefully at the end of this I'm going to make a point, because we all know when you give a Wolverine an inch, you know. Franklin, we're going to talk about Franklin. It's a historic district where I'm going to kind of use it to generally talk about all communities, though, because there's, other than, you know, another couple layers of going through some SHPO and that, I mean, dealing with a historic community is really no different than any community. So we're going to talk about Franklin, but then I'm going to try to bring it home with some more generic issues. Franklin's a small community. It's in Oakland County in Michigan, if you're familiar with that. It's a northwest suburb of Detroit. About 3,000 people in 3 square miles. It is a very historic area. They have a cider mill right in the middle of town. You know, so there's obviously some issues that we had to deal with. The good thing is when we went in there, it started off as a recognized need, and this is a, you know, a photoshopped generic drawing of a coverage that, you know, carriers were looking at. Pretty true to form. I just didn't want to throw any carrier up there in specific. Basically, they were, you know, a community that was surrounded by cell towers, and they recognized they had nothing, and they were struggling at the time with what do we do to get coverage. The good thing is that we did have some council people, one councilman in particular, who recognized that, you know, listen, we're an upscale community, we need wireless in here, and for a lot of reasons. So they'd already started looking at it. I mean, they were struggling over putting in a cell tower at their fire station, which is kind of in the middle of this thing, and half the council's looking at the revenue side of that, because every community, and especially in Michigan, is no different. They're looking for revenue. And they were also struggling with the aesthetics of it. Fortunately, they decided that, you know, we need a long-term solution, and even in this area, throwing one cell tower up there, and this was back in 2004, they recognize that that's just not going to be enough in the future for capacity. They went out and did some studies and said, you know, there's people going to be using this for a lot of other things. Data really hadn't even started yet. So our main issue is obviously the demographics. In this case, Franklin's a high-income, high real estate area. There's no doubt about it, and that leads right back to aesthetics. The issue is they knew they wanted something. There is just a ton of topology, a lot of what, you know, everybody in this room calls, you know, clutter. It's not easy to cover an area where the streets are all going up and down. You have a ton of trees, especially in the fall. It's completely different in the winter. In Michigan, we lose a lot of our leaves. That was a big issue with doing a design. And the fact that this was a new technology. I mean, this was 2004. Communities hadn't really heard about DAS yet. I mean, we hadn't really heard about DAS yet, a lot of people in this room. So the good thing is, and this is especially true of a lot of historic areas, the one good thing is there was a lot of above-ground infrastructure, which is pretty common for historic areas. And, you know, a shout out to DTE Energy. They were a wonderful utility company that got it, let us put stuff on their utility poles, and to this day they've been an awesome company to work with, and it's you know, it's worked well for communities in Michigan. It took a few meetings. We had to have educational meetings, and it wasn't just us educating Franklin, right? They educated us too. I mean, it happens. The wireless industry is like any other industry that gets out in front of a planning commission and council. Nobody likes to be told how to build their buildings. I don't care if you're Walmart or if you're a gas station or whatever. It happens. So, you know, we try to take away from those meetings as much as we try to provide. And in this case, we did have to go in and kind of, you know, educate Franklin about what a DAS network was. They never saw it before, never heard it. They did bring in a consultant who, you know, lucky for us, verified everything we said. He says, yeah, DAS seems to work. It's been around forever in other forms. And this is a good application for it. So it worked out well for us. Now, I want to kind of bring that over to the more generic side of that and discuss an issue that we see happening. You'll hear this called a lot of different things, edge of cell dynamic and what have you. But I want to try to put in layman's term what's going on with the cell sites out there. I mean, it's kind of the equivalent of we're the first 4 people to show up at a party. I can stand 30 feet across the room from you, and we can carry on a conversation. Now, the party starts, and the other 200 people show up. We can no longer stand 30 feet apart from each other. We have to move together to carry on our conversation. And then I threw a picture of U of M Stadium in there for you, Mary. And so that's really what's going on. And the cure to it is just, it's common physics, right? We need to get the antenna closer to users. And really the point of these pictures is nothing except for, you know, here's a residential area, here's a commercial area, kind of a downtown core area. We're still building out these networks. We're still expanding them. And I think the beauty and the point I try to make is even though these antennas are right across the street from a person's house, and they are throughout this entire design, to this day, the community has never as so much got a phone call from anybody saying, what's that stuff out there? And, you know, a matter of fact, in one different state, I had to do one. We literally had to send out over 5,000 public notices to citizens because of a network we were building. Over 5,000 of them. You know how many people showed up at that public hearing? Not a one. 0. I think for the most part, people don't care about this stuff because they can't see it. So now I'm going to get to the one slide and try to bring home a point. The top here, I'm trying to show what wireless provides, period. Whether it's DAS, whether it's cell towers, whether it's rooftops, whether it's anything, wireless provides these things. We get back to this essential services argument, and it's like, come on, are we still really talking about that? As the city planner, I'm very familiar with essential services, what they mean. For the heck of it, last night I got a Muni code and Googled a few more definitions, and it's still out there. Essential services are still defined as including telephone services. And yet, you know, communities have a habit of, and in some cases they've actually changed it to say, but it doesn't include wireless. So we need to move beyond that. The communities do. It's an essential service. People are using it as a telephone. If you want to take the definition out, fine. We've been saying forever it stimulates economic development, competition, services. The civic engagement one is funny. I mean, it does improve access and civic engagement for the citizens. And I find a beautiful irony in getting text messages from homeowners associations to tell people to come on out and fight the cell tower. It's just, you know, it's wonderful. They're embracing the technology to use it to go fight things. But, you know, it does happen. It improves efficiency within municipalities. I mean, the tablet thing, imagine the plumbing inspector who goes out and does an inspection on a house, gets done early, and doesn't need to go back to City Hall to go to the next house. He simply gets on his tablet, downloads the plans for that building, and moves on. And so that is available out there for communities to start embracing as well. Now, DAS, it's ubiquitous, it's non-intrusive. Again, it's been said, DAS is just another tool in the toolbox. It's not a cure-all. We need cell towers, we need everything. This is just a way of doing it. It's a reliable system, it's secure, it is open and non-discriminatory, right? We build open networks. It's up to us to try to get everybody into the community. Cost-effective, greater technology. I think my message I'd like to try to drive home is this, that there's benefits that communities can provide for their citizens, their residents, their businesses. They don't always have to be economically driven. All right, you don't have to extract something out of every developer and make the benefit to your community financial. And I would hope that wireless technology is one of those things that communities would start embracing. Franklin did it. They did it because they wanted wireless coverage for their residents and businesses. They didn't do it because they wanted money. And I think that's the message that I hope I can make, is that this is a benefit and it doesn't have to be written on the check of the wireless companies. Thanks.
Thank you, Dave. Dave, you mentioned SHPOs, and our next speaker is the former State Historic Preservation Officer for the state of Ohio. Amos Loveday was also the former FCC Federal Preservation Officer, and he is a noted historic preservation consultant. Amos will describe how the major restoration of the Chicago Mercantile Building included a dynamic wireless system while maintaining the historic character of the building. Amos?
Thank you, Dan. I always begin these discussions with the cellular community, wireless community, saying, or asking a question. How many of you have met a SHPO? How many of you have cursed at a SHPO? When I first took the job as SHPO in Ohio, my daughter was in the 7th grade, and she was doing one of those things at school where they tell what your parents did, and she said, my dad's a SHPO, and her friend said, my dad's a doctor, and he can cure that. So I come at SHPO-dom and historic preservation with perhaps a little more sense of humor than most. I'd been here at the FCC for several years, and shortly after I left, I had a call from Singular, Ben Albin, as I recall, and he said, Amos, we have a problem in Chicago, and I wonder if you could help us with it. Singular was installing an in-building system. I don't know if it technically was a DAS system or not, in the Chicago Board of Trade. And Chicago Board of Trade and Mercantile were merging at the time, and the merger sort of depended upon getting this thing done pretty quickly. And he said to me, he said, we have about 30 days to get this to the SHPO's office. And I said, well, you know, we can do miracles, but I don't know if this is one that's possible or not. We'll try and see. So that was my initial introduction to in-building systems. What I found in working with this particular project, and I've since worked on several other projects, is that from a preservation perspective, in-building systems, DAS in-building or small cell in-buildings, whatever technology or terminology you use, actually can be fairly easily gotten through preservation channels, because preservationists, if the projects are presented correctly and explained to them, clearly understand that this is very beneficial to historic preservation. This is the type of technology that preservationists have really been praying for all time, since the very beginning of the cell industry, because, as Dave says, it's even outdoors, it's not an intrusive technology. Aesthetically, it can be blended very easily, And it provides a level of service that revitalizes or at least makes historic buildings equally usable as modern buildings, because we all know, particularly old masonry buildings, the stone buildings can sometimes be very, very difficult places to get cellular communication. So I'd like to share with you just a few basic principles in dealing with historic buildings today and installing in building systems. Don't want to get too detailed. Be happy to talk to anybody afterwards or at some point more detail about it if you want. But essentially understand, figure out how to make this work here. Okay. Understand that preservationists are really dedicated to making old buildings productive. That the whole gist of American preservation is to keep historic structures in productive use. Few exceptions, the monumental buildings that are museums, but most buildings like the Merck building, the Chicago Board of Trade building, would have no useful life if it couldn't be economically productive. Just like a stadium. A stadium without a sports team is a pile of rubble. And when it's no longer usable for that purpose, it's destroyed, and preservationists don't want that to occur. So there's a predisposition on the part of preservationists to work with you when you put these systems in to make that building a productive building, because they know that making it productive will keep it in use. Also keep in mind, and this is what we found out when we got to Chicago on the Merck building, that it's not just the state historic preservation offices, the so-called Section 106 rules that often come into play when you're doing an interior system in a building. A good many of these buildings will be upgraded at the time they're doing general renovations, and those are often done under tax credit projects that are administered through the National Park Service. In fact, the problems that Singular was running into in Chicago had to do with tax credit rules, not 106 rules. And tax credit rules are administered by the SHPO, but there are a different set of rules that you need to be aware of, you need to work with. The good news is that they're not terribly complicated rules once you get into them. They're easily accessed. If you look at that web page that I've listed there, you can see what they are. And more importantly, there's an established industry that works on tax credit projects that will often be managing the projects or actually undertaking the projects that if you get too early in the process, you can build in your systems, the cabling if you need cabling, the locations of the antenna right into the construction plans, and there'll be a seamless process of introducing these. This is what we did and eventually ended up doing at the building in Chicago. We did a temporary installation until they got the renovation underway, and once they did the serious renovations, then we integrated the system right into the construction that was going on, and it worked fine. The SHPOs and even in this case, we went to the advisory council said it was perfectly okay for us to put a temporary system in until the construction work was completed, and we showed to them that we were integrating this into the system, the construction plans. We also pointed out to them that we were going to be avoiding some of the more sensitive parts of the buildings. The lobbies in the Merck building, it's an Art Deco building. Some of you, I'm certain, have been in the building, the Chicago Board of Trade building, rather. It's an Art Deco building, and those lobbies are marvelous scenes, and we clearly stayed away from those. The one instance where we had to go into the lobby, we hid they hid it behind the panel. As a matter of fact, in the lower corner of that slide is one of the panels that the one with the tractor on it that we hid the antenna behind, so that nobody could see it. And as Dave, you were saying, when these become invisible, people simply forget about them. I'll also say to you that I haven't seen a historic building yet, office-type building, hotel-type building, where DAS technology can't be easily accommodated. If you just plan ahead a little bit, work with the architects that are doing the development on it, if it's a part of a general project, and if it's not a part of a general project, if you bring on somebody that has a little sensitivity to the building, all due regard to engineers, you're great at making it work, but you got to find those architects that know how to make it look right. And if you do that, you're gonna find life pretty easy. The clincher on this one was when we showed up to make our case to the SHPO down at Springfield. We walked into the old state capitol building where our offices is, and lo and behold, looked up, and on the ceiling was exactly the same type of antenna that we were planning to put in the building. We simply took a photograph of it with our digital camera and showed it to them in the office, and they said, well, that looks really familiar, what you're doing. We said, of course it is. It's right outside your door. And after that, we had no difficulty. We made it in 18 days.
Thank you, Amos. Last but not least, our next speaker is Joe Mullen. Joe is a Vice President of Engineering and Operations with Insight Wireless. Joe has more than 25 years of experience designing and deploying wireless networks, including experience developing specialized in-building coverage. Joe will be discussing with us the Boston, Massachusetts DAS system, which allows commuters to use their broadband equipment underground. Thank you, Joe.
Dan, thank you very much. Get that work. That's pretty good. Just as a matter of introduction, Insight Wireless is a wireless infrastructure company. We have 450 towers, also 16 DAS systems, and we operate as a neutral host provider, which I heard the term mentioned before, and just to kind of share what that means is, in SES terms, we kind of drive the carpool. We ask get the carriers to come along for a ride, but that's what makes it all fun. And so in the way that it would typically work is that we would make our own capital investment in the DAS system, and under an agreement with the venue, the host venue, and then the return on our investment comes from the carriers by paying to use the system. As an example of some of the other public spaces we're in, to give a little context, we're in some convention centers. We're in the Moscone Center in San Francisco, where Macworld just wrapped up, and talk about a place where everybody wants to have the latest and the greatest ability. When you're rolling out the latest high-tech device, you want to have your 4G, LTE, 700 megahertz MIMO system and have it working well. And so it's very much a very visible venue. Similarly, we have the Boston Convention Center in Boston, where there's a gaming show that comes in. About 20,000 people line up to see all the latest new video games, and guess what they're doing while they're waiting to play the games? They're standing in long lines like Disney World, just on their smartphones, just surfing the web and texting and doing all kinds of other stuff. Entertainment venues, we're at Wynn Las Vegas, we're at Summerfest up in Milwaukee. It's an outdoor music venue. Sports facilities, Minnesota Twins, US Cellular Arena. At transportation, we're at an airport, and transit system, MBTA, which is what we're here to talk about. A little bit of the lead up on the MBTA, going back to probably the say the turn of the current century. Wireless carriers started approaching MBTA and said, hey, we'd really like to provide coverage to our subscribers underground. We're getting a demand for it. And as multiple different carriers came in and wanted to deploy their equipment, MBTA started looking at it and said, well, wait a minute, we don't want to have all this different equipment throughout our stations everywhere else. We're looking for a more of a consolidated approach. And they went to RFP, and what they envisioned and what we've since developed is a distributed antenna system. All of the carrier equipment is off-site from the MBTA. In our facility, it's a base station hotel with like the pictures you saw here. And we go from there out on fiber optic cable throughout the whole subway system to each station and nodes between stations to deliver the signal. And just as a reference point, start with what's on the slide there. Right now, there are more than 220 million riders per year on the MBTA. That's a modern record. That's actually a record for the MBTA since it was created. You have to go back to 1946 to when there were private subway companies to see a higher number of ridership. A typical weekday, you see 795,000 riders on the subway, and that's growing at about a 5% year-over-year rate. So as the gas prices go up and congestion increases on the highways, a lot of people are going to the subway. There's 35 underground stations and 19.5 miles of track and tunnels that we cover. The majority of that is covered by, or we try to cover as much as possible, let's put it this way, by antennas, where the tunnels are fairly straight and wide. Antennas work pretty well. When they get narrow and windy, then we go to a radiating cable. And so if antenna is a sprinkler, okay, watering your lawn, the radiating cable is like a soaker hose. We mount it on the wall of the tunnel, and low-level signal emanates from that hose into the train all the way along. It runs about a quarter of a mile for each section before we have to have another amplifier. And speaking of which, we will have, when we're done, about 100 remote node locations. And with the anticipation of MIMO 4G LTE, which the carriers have not rolled out yet, but we are expecting, as well as the AWS, we're expecting about 550 amplifiers, and we will have about 14 miles of radiating cable alone, not counting the cable that goes to the antennas, 422 antennas. So it's a pretty good sized system. So moving along, I think the benefits that we see here from the from the DAS is that, well, first of all, there's no coverage down there, so it's definitely coverage driven. The other thing we're seeing is that not only is it coverage driven, but as the carriers get in there now, we're seeing a lot of capacity increases, just as we've been talking about with the smartphones and the demand for data. And so what the benefit to the carriers is that it provides an increased service to their customers. It delivers that data that wouldn't be delivered otherwise, and it results in customer satisfaction. For the riders of the subway, you can carry a conversation from above ground down into the station, on the subway, through the tunnel, back up above ground again. It's contiguous coverage from end to end, not just in the station, but all the way through. And so you can basically have that kind of continuity. Also from the data side, you make the time that you're on the train or in the subway productive. Email, text, you can get directions. If you're going to the airport, you can check your flight status, see if you really have to hurry. You can, even if you didn't quite get around to it, check in for your flight on your smartphone. So there's numerous benefits for the rider. For the community, there's a public safety benefit also. With all these people down in the subway, if there is a crime, they have their phone right at their hand. A medical emergency, same thing, or a suspicious package, some sort of security threat. Once again, it benefits the community. And for the transit system, well, it provides revenue. There's a revenue piece that goes to the MBTA. And there's also a reduced cost for them of distribution of information to their riders. And also, it's a driver that, if you can be more productive on the subway, it's going to help increase that ridership. I think probably the $5 gasoline will probably drive it a little bit more, but DAS is going to help. And so, going here, I think this is just a little bit of a highlight of where we're at today. We have 26 stations, 13 miles of tunnels, and we see that typically a rider spends 10 to 15 minutes underground. They can use that time, make it worthwhile, and we are slated this year. We have 9 stations left to complete in 2012, so that we will be complete underground, the whole system. And this basically shows our rollout. The blue is what's been operating up until now. The yellow are the stations that we just completed in 2011, where the carriers are in the process of turning up, and the remaining 10 stations are our 2012 build. And this is something that's very important to the MBTA. This shows when we started service on the Orange Line, the general manager came out. He brought the chief of police relative to the public safety benefit. and it was a good opportunity for a press conference. It was coincidentally his first day in the job. Maybe he was looking to do something, I don't know. But anyway, it was a nice event. And the other thing, coming back to the one of the key benefits here, and that this is something that nobody predicted, I don't think, going into this. We were talking about when we were going into the DAS system, we were saying, okay, well, smartphones, communication, maybe, that's down the line. Let's talk about communications. Let's maybe do some texting. Who knows? But as it turns out, what the MBTA has done is opened up their real-time live traffic data to third-party developers. And there have been, just as the right side of the slide shows, there have been a ton of apps that have come out from these different developers. Most of them are free. And if I'm leaving my office, I'm going to a meeting, I can look on my smartphone. I can check when's my next train coming. If it's 2 minutes, great, I'll go down, I'll get on it. If there's a delay for some reason, hey, I'll find an alternate route. But this is one of probably the biggest drivers and the biggest benefits that the MBTA has seen from having a DAS system down there. So that basically is a summary of where we're at, and we're just looking for more people to join the carpool.
We would now like to direct the questions that we've received to the panelists, and Don is going to take care of this portion of it.
Well, first, we have received several questions that are regulatory in nature, and per the ground rules that Cecilia had spoken, that we're not going to get involved with those questions. But so I think we'll first go to Marty. And one of the questions, as a sort of a two-part, one of the questions was that what, if any, effect will DAS small cell equipment have on the existing medical equipment in hospitals, such as pacemakers? And then the second part of it is, do you see that when a hospital puts in or constructs an in-building wireless system, the value proposition versus other hospitals that don't have that kind of a system?
On the first question, I'll as opposed to talking about pacemakers, I'll give a very real example of something that happened recently. The unlicensed spectrum space, of course, is wide open, and so folks flock to that. Medical device makers will flock to it. So when we think about 5 rights, meds administration, and the necessary safety protocols that go into making sure that the right patient has the right medication at the right time and the right dose, and I forget the 5th right off the top of my head, to think that if that is happening over unlicensed spectrum, or if a wireless smart pump is infusing and being programmed through unlicensed spectrum, and then of course passing its data back, it raises questions around the real safety involved in those kinds of devices. There really is no assurance. In fact, recently, I believe the FCC allocated spectrum for mobile body area networks, which is very close to channel 1 on the 802.11 spectrum. And if someone were to have a device that was ill performing in that area, and they stand next to a patient that has some sort of smart Band-Aid or something like that on them using this frequency, what does that do to that kind of care? It raises questions around it. And so by using the licensed frequencies inside of small cell architecture, you guarantee yourself a well-performing block of frequency that, if it could be privatized for the use of medical care, would deliver the kind of assurance that you know it needs. Furthermore, as the patient leaves the ICU and then eventually goes home and they're wearing some sort of body monitor and you need to collect those statistics, if it was using one of those cellular frequencies that you had privatized inside the hospital but now is readily available to them in their home, it's going to guarantee that superhighway of information that we're looking forward to in the future, of being able to collect all this data, medical data, no matter where that patient is, whether inside of your building or somewhere else. Your second question, can you just remind me what that was again?
What I was asking there was...
I remember. I got it. With healthcare reform, at least in California, we see that the fight for who attracts what patients is going to be huge. Institutions are going to have something that differentiates themselves in terms of services that they can provide to the patients and their families, not only during their hospital stay, but when they leave as well. And I think in terms of in-building services, and that's why we have them defined as consumer, enterprise, and medical grade, to be able to provide even those basic consumer cellular services so that they can use their apps, stay in touch with family and friends, have the support that you typically need inside of a facility. That is going to distinguish places of care. I wouldn't say that, we're still going to say the institution with the reputation of excellent care is still going to win out. But if I go to that institution and I know that I have all of these other concierge type of services, some of them we even consider now birthright services with wireless, it's going to be a differentiator.
The next question for Seth. You had mentioned a shared DAS coalition. And a question here is, what organization do you see initiating that, or how do you see that possibly working?
Sure. Well, we're initiating it, Solid Technologies, but a coalition without members doesn't make much sense. So we have other integrators from the integration community. They're the ones responsible for sizing up the opportunities in the market and deploying. We actually are working with an accredited certification program, not ready to announce it yet, but it will be with a university out west, which ties it to their telecommunications master's program. We're working with representatives of the public safety community that transcend all the different branches that cover the first responders, trying to make sure that they will get on board, particularly in the area of certification. What we have now, with all due respect to the Commission, is we have certain certifications that show up in code. They may reference Boston. Just yesterday I was reading it. It says that when you install a public safety DAS, it should be approved by an FCC certified technician. It should, or somebody that's certified by the PCIA, which is the Wireless Infrastructure Group, or APCO. From a cellular DAS perspective, none of those certifications are relevant to the issues that are being debated between the cellular industry and the public safety communication industry. Not because those certifications in and of themselves don't check the box for the local AHJ, but because those certifications don't check the box and aren't recognized by the cellular providers. And since it's the cellular providers who are funding, for the most part, these DAS systems, the coalition's goal is to start a communication process whereby we can agree on, at a national level, this is what a good, safe, shared DAS looks like. Recognizing all final certification will always happen at the local level. There will be a local RF engineer from each wireless carrier who said, yes, I bless this because I have to control this. And there will be a local communication officer from that public safety agency or AHJ who says, yes, I bless this. But those systems will never get implemented if, as a coalition, we don't begin talking more.
And thank you. And then for David, question about the in-building systems and for first responders, and it went to using or the lack of using antennas in stairwells and garages, the places where they have to be attacking a fire, for example.
Sure. And Actually, I want to dovetail just on the end
That's
of
fine.
Seth's response, which is, I couldn't agree more. And then what I think needs to be clear is that conversely, the carrier certifications that we're demanded to carry don't transpose themselves into the public safety world. So they're not only two different technologies, but keep in mind, public safety is generally not wrestling with capacity issues and the interference that the cellular carriers often struggle with, and the macro networks in the cellular world are much more complex. So it's really twofold. So with regard to antennas and stairways, and we get this often, really it's there's nothing that precludes an integrator from putting an antenna in a stairway, or a stairwell, I should say. It's really the requirements that are driven around this. So if we look at the economics of what does a cellular carrier look for, if you could envision a pie that's split into three pieces, right? There's the customer demand, then there is the customer demand in terms of how they're using the devices and the reliability that they expect on the devices. And then from the carrier side, there is it an engineering issue? Is it a capacity issue? Is it merely an offload of the macro network because of the users that are in the building? And then the carriers share another piece of that pie, which is do they risk losing users if they don't put coverage in there? And then also, how many additional users can they gain if they put coverage in there? And all those metrics move. Unfortunately, the cellular carriers don't target stairwells as a primary area for coverage because we're looking at DAS systems generally in multi-story buildings, and most tenants don't use the stairwells. They use the elevators, which brings in to another discussion of elevator shafts, which we get much, much more often. And simply by code, we're precluded from putting RF components and cabling in those elevator shafts without some substantial exercises and getting exceptions, and it's just impractical. The way we overcome that is we design the RF to cover as much of the elevator shafts or the stairwells that we can by putting antennas in proximal areas to those shafts and the common access points.
Thank you. And for both Dave and Mary, since the campus has so many different buildings, question about the infrastructure when you have a situation when you're using, where you're looking at fiber here or coax cable here or a twisted pair wiring, and how do you approach that when you're maybe going from one building that's an older building, it's an old coax, to maybe a new building that's fiber related, and et cetera.
The one thing about the university campus, and this was, we did have to educate Extenet about this, is it isn't just one single infrastructure, everything's the same, come in and build it. We're actually a lot more like a city. So the buildings, the campus has been in existence since 1817. So there's a lot of history there. We do have a fiber infrastructure that runs around the whole campus. The in-building fiber and facilities we've made accessible to Extenet to use. The physical connections, I'm not sure if that was the question, or is it just the complexity of, I can describe the architecture. We have on the campus, there's the base station hotel that was mentioned, and that's where the carriers have their BTSs. It's where the head end is. And then there's fiber distribution from that point to all of the buildings. That's our backbone fiber. And then inside the buildings, there's the remote nodes that are wired by coax to various antenna points. And when I talked about the cost of that, we understand the complexity and the cost, and what we'd like to see is a way to help reduce that cost, whether it's the new base stations that may come out, whether it's a new antenna technology that allows us to not have so much in-building wiring. The fiber backbone plant really isn't a big issue cost-wise. It's in place. We have had to augment it here and there, but that isn't a primary barrier in any way. So I don't know if you want to add anything, if that answers the question.
Yeah, and I think the only thing I would add is working in the older buildings with the coax, again, back to local codes and practices, we've had to put everything in the conduit, so installing conduit in old buildings and risers is very difficult and very expensive.
Thank you. And for Dave Snyder, we had a question about, you had talked about the village of Franklin and the upscale nature of the community. And the question came in as, do you see DAS or small cell in just the average neighborhood or whatever, or for the average user?
Yeah, I think obviously when DAS first started out, it was really a good tool for high-end communities that were really, all they cared about was aesthetics. They just didn't want to see the antennas. Now, though, we've built demographic-wise in a lot of different communities, and some communities that the niche there is prepaid phones, and the carriers knew right out of the gate the issue was not aesthetics, the issue was capacity. And I think nowadays, the advantage of DAS is that it hires, it allocates capacity in a very unique and effective way. And so you still have DAS as a tool for aesthetics, but you also have DAS as a tool for capacity issues, and that's just getting the antenna closer to the people. So I think demographically it doesn't matter anymore.
Thanks. For Amos, you had mentioned tax credits. Could you talk some more about that?
Yeah, the National Historic Preservation Act and the rules that implement it make available to people who restore historic buildings, that is, income-producing buildings, such as offices, hotels, and the like, tax credit for the work they do on those buildings. There's a federal tax credit and there's a state tax credit. And these are often paired with other types of tax credits, such as facade easement credits and the like, so that many of these historic restorations that you see, commercial buildings, particularly hotels, and office buildings, such as the one in Chicago, are funded largely through tax credits. Typically, the developers will put together a syndicate of investors where the building owner brings to that syndicate the tax credit and draws the money out and uses that the tax credit that is used by the for-profit investors. It's common. It's sponsored by, as I say, the federal and the states. The National Trust for Historic Preservation, for example, has a whole section devoted to that. Several banks participate. When I was in Ohio with SHPO, I was there for 5 years, and give you some sense of how big it was then in the early 2000s. In the space of about 4 years, we did $500 million in tax credit work for commercial buildings, mostly office buildings, hotels, mostly in the big cities such as Cincinnati and Cleveland. I would suggest anybody that's interested in working in this with historic buildings get to know that tax credit business, get to know the contractors and the consultants that work in that area, and you can probably piggyback onto the work that they're doing there to install these systems that you're looking at.
Right. Thank you, Amos.
And last but not least, Joe, talk about sort of the RFP process, because a lot of times people think about it in the commercial, they don't think about it, in a request for a proposal, but in the, is this an opportunity for like the transit authority, other transit authorities, campuses, communities, buildings, whatever?
Yeah, anytime there's a, we go through RFPs in a couple of different scenarios. I mean, usually in the public sector, where there is a any kind of an involvement of a procurement process, there'll be an RFP to go through, and that was the case on the MBTA, obviously. but also we run into it in, in convention centers. They're typically owned by some governmental authority. There's also private RFPs. For example, the Minnesota Twins. They don't own the stadium technically. They manage it and operate it. There's a governmental agency that owns the stadium, but the Twins put out the RFP as a private party, just to get responses. So there's a whole series of RFPs coming out periodically. A lot of the sporting, I think we've heard about here, sporting arenas, stadiums. Public transit has a couple in play right now. So it's a matter of just responding to those that are out there.
All right, thank you, Joe. Well, once again, we would like to thank all of our panelists for their highly informative presentations. Thank you.
Start back up at 1:15, and as I mentioned earlier, we do have a lunchtime speaker today. He also brought some equipment with him, so that's what this equipment is up here displayed. So if you get back a few minutes early and want to take a look at that, Brian Domingo, if you want to raise your hand there, he's going to be our lunchtime speaker. If you go out, go to the elevator lobby, there you go to the CY level, and there's some ladies in the back by the doors that can direct you if you need help getting to the cafeterias. Since it's a pretty nice day out and we've got a little over half an hour, if you go out the front doors of the commission and turn left, up at the next corner, there's a little deli, and if you turn the corner and go up the hill towards the Mandarin Hotel, there's also a Potbelly's there if you want. Feel free to bring your food back here and eat here while you're listening to the speaker if you want to. So we'll convene back here at 1:15, and thank you to all the panelists from this morning. So we're going to go ahead and get started with our lunch speaker. We're going to have a presentation, and then we'll have a few minutes for questions and answers after. So again, if you have questions, I'll be roaming around, and there'll be one or two other people. If you want a note card or you have a question, just raise your hand and we'll get it to you. So our lunch speaker is Brian Domingo, who is a business development manager at CommScope, and he's going to discuss DAS deployments in sports stadiums.
Good afternoon, everybody. I'm happy to know that I actually have the first spot right after lunch, so everybody's fed, everybody's wide awake. It's always a challenge right before you're actually cutting off for lunch when you're going to present. So I'm happy to be here today to represent my company, CommScope. For those of you that aren't aware or are familiar with CommScope, CommScope is one of the leading RF suppliers for RF infrastructure in the entire wireless industry. So primarily every component that goes in an RF system that isn't involved with an actual radio, for example, a base station or anything of that sort, our equipment is used in every single type of system that's deployed throughout the world. But for the sake of this discussion, primarily in the areas of distributed antenna systems, our organization was tasked with talking about what we've done, particularly in case studies involved with sporting stadiums and large venues. Our organization basically are pioneers in the wireless coverage solutions. This slide clearly depicts the three major segments that we've actually been very successful in doing large-scale deployments, ranging from commercial applications, operational type of applications, or public safety. The commercial space predominantly is surrounded working directly with the BTS manufacturers. So the Motorola's, the Alcatel-Lucents, and several of other radio manufacturers in that area. But primarily when we look at zeroing in on distributed antenna systems, public safety and operational strategies come forth. So coverage extension solutions for wireless operators, primarily in the 2G and 3G and now 4G environment. We're heavily involved with discussions with the strategy in that environment. And we have a very long history supporting public safety agencies, primarily with private trunk radio systems and LMR space. The bottom line is, to take away from this slide, is that CommScope has implemented more large-scale, high-profile wireless coverage projects than any other company in the world. The next couple of slides detail some of the different types of examples of areas in convention centers and other public venues that we've actually been involved in. On this slide, case studies, for example, HP Pavilion, Madison Square Garden, and KFC Yum Center were some of the early adopters of understanding DAS. A lot of the topics that were discussed earlier were centered around who actually owns and runs these type of distributed antenna systems. And in our answer, it's basically a wide array of different types of solutions that come to market. You know, whether it's the actual venue owner, the property building owner of the facility, or primarily in arenas and convention centers, whether it's agencies that are responsible for maintaining or operating the actual centers themselves. We've been involved in negotiations on behalf of our organization along with carriers to evolve distributed antenna systems. Some other clear examples that have borne adoption based off of funding are university sport venues. Once again, this is just a snapshot of the dozens and dozens of other sporting venues at the university level that we're actually engaged in right now. But these are actually good examples of systems that have been deployed using our equipment, primarily in the areas of University of Notre Dame, where that's a system that was augmented with a single carrier but has now grown to the point where it's actually a neutral host or potential neutral host for other operators. Other examples include Arizona State University and definitely the UT Austin. Our group is headquartered, or our business unit in North America is actually out of Richardson, Texas. So we have a very strong focus and partnership alignment with that particular state and region. So we have a lot of other different types of examples of where our sporting venues have come to market. Baseball stadiums. A comment was made earlier regarding timeliness of deploying systems. And as you can see, just based off of the different arrays of sports that actually occur here in the United States based off of seasons, our organization is used to working with strict timeframes and deadlines for deployment. Baseball stadiums right now, we're in the off season, but our teams within CommScope that are responsible for doing design, integration testing, and full turnkey support for our wireless operator partners and integration partners are currently working on projects throughout the United States. Some baseball stadiums that we currently have deployed our equipment include AT&T Park, Turner Field, Petco Park, Safeco Field, Citizens Bank Park, and we just recently received word that Wrigley Field is actually scheduled to be on date before the start of the season. So that was a nice system that we actually deployed. Football and soccer stadiums. Outside of just looking at the United States for the NFL, CommScope is a global organization with distributed antenna system projects throughout the world. So we've done a lot of work primarily in the UK, definitely in Europe, and definitely the Asia PAC rim environments. Cowboy Stadium, which is a case study that's true and blue to our organization, is something that I'll walk you through as far as a specific case study on what we've done from initial design all the way up to full-scale deployment. But some other examples of football and soccer stadiums that we've deployed include Cleveland Brown Stadium, UK Commonwealth Stadium, the Georgia Dome, and the other stadiums that are actually listed on here. Now, knowing that you see what CommScope's depth and expertise is in this entire environment, I'd like to walk you through specifically some examples as far as what we've done with the Dallas Cowboy Stadium. First and foremost, regarding any type of public stadium, the key requirement is to understand which operators need to be discussing access to the stadium. Obviously, there's a vested interest on behalf of the Dallas Cowboys or any type of venue owner, but every operator that's actually responsible for maintaining a network in the United States, in North America, or any other region throughout the world needs to understand the impact to their network. Clearly, we understand stadiums draw 200,000, 300,000, maybe even larger numbers of people within a stadium, and the networks have pretty much reached their limits as far as macro level support. So over the last 5 to 6 years, we've seen a very strong trend moving upward as far as supporting distributed antenna systems in these type of large venues. So the first scope, definitely for the Dallas Cowboy scope of project, was understanding which commercial wireless service providers needed to be part of this entire venue. Independent of that, obviously the public safety requirements needed to be detailed, whether they relied on 700 or 800 megahertz in operating frequency, or whether it was a UHF or VHF type of system. Once the requirements were nailed down, the next step is understanding what type of capacity requirements are needed. So case in point, every operator here or even a public safety environment clearly has license to operate within certain spectrum arrangements, but we need to understand what type of channel assignments and what type of capacity is going to be drawn into the network. Once that's done, our design teams begin a site walk assessment with the entire stadium. So what we do is we walk floor by floor basically seat by seat in the stadium, what the target coverage objectives are throughout the stadium. The important thing to understand is that once we identify where the key traffic areas are, we have to understand, based off of carrier feedback, what type of applications are being used. In the enterprise space, whether it is commercial point-of-sale terminals, in the marketing and advertising space, whether it's streaming video, streaming media, our organization takes the time to understand what is it that the organizations that we're trying to service, what are they trying to move through the entire stadium demographic. The final outcome is what we call a zone and sectorized plan. This illustrates the way Dallas Cowboys Stadium was mapped out from our lengthy site walks within the venue itself, but also identifying how we want to zone and identify the geography within the stadium. Now, this is important for two purposes. One, initial coverage footprint for an operator, but number two, growth strategies for each operator or each type of commercial service that's being deployed. So looking at the slide, a good example is when you look at Sector 1. You see Sector 1 on the far left pointing to 3 arrows, which is Zone 3, 4, and 6. Yet Sector 2 only has 2 zones. What we do during the design phase is we define finite zones that can be serviced either one-to-one with a one-to-one sector mapping per sector, per zone, or one-to-many type of zones. The important thing here is emphasizing the flexibility of capacity that we promote to every neutral host type of application, every provider, that their design requirements and their coverage requirements may change as capacity increases and subscriber uses increase. This is no different in the macro world as cell splitting, and it's no different than what we're doing in the distributed antenna system environment. This illustration shows you what our head-end equipment looks like within the Cowboy Stadium. It's a very large system that was deployed. We basically have 2 dedicated DAS rooms ranging between 20 to 30 different types of head-end systems that are managing the multiple sectors and multiple zones. As was mentioned to my left, to your right, over by the display, I actually have equipment that details what our head-end unit looks like, along with the actual physical remote that's deployed within the stadiums. The head-end units are obviously daisy-chained, so as capacity increases, our system can scale and grow as the venue increases in capacity and demand. This could be done at the venue level, it could be done at the carrier level, and it could be done at the operator level. The green lines represent several different types of fiber optic links that are used for extending large capacity sources to interconnect systems, so they don't have to necessarily be in the same physical geography within a building, very similar to what we discussed earlier as far as base station hotels are concerned. We treat data center deployments the same way as far as staging our head-end unit for staging and deployment. The next couple of slides will just detail some of the pictures and examples of the live deployment of what is in Dallas Cowboy Stadium. So this here is a great example of the head-end equipment that's housed within enclosures that are secured. You can see a lot of empty slots. Our system was designed with a 4 to 5 times more capacity that can grow into the system. So we have several space and slots that are needed if by chance additional carriers, additional sectors need to be deployed. Here are some great examples of different types of stadium antennas that were used in Dallas Cowboys, in the Dallas Cowboys Stadium. The sectorization panel type of design from our propagation perspective can range from an omnidirectional 360-degree footprint to something that's more directional, whether it's 30-degree or 65-degree beam widths. The important thing is tying in the design with the initial requirements, understanding where and how coverage is needed within the venue. We make sure that we scope out and spec out the proper antenna in the RF design. Nonetheless, when the system was deployed, the biggest truest testament was our ability to support Dallas Cowboy Stadium during last year's Super Bowl. The attendance was pretty much, one of the largest stadiums that were deployed for any type of sporting venue. We were happy to know that our system deployed at a very simple level. It was deployed with green light status throughout the entire venue. I don't have the metrics per non-disclosure, but I can guarantee you that 3 of the top operators achieved call levels that were in the single digits, if not better. So their KPIs were in line, and they were very satisfied with supporting the call volume that was actually transpiring in the system. With that, the toughest part about doing a lunchtime presentation is I only have 10 minutes to present. So with that, would like to open up the floor for questions or anything?
We're going to do it like we did this morning with the note cards, so that, because if people just yell them out, they won't be picked up for the webcast. So if you have questions, just raise your hand and we'll get a note card to you. Have we gotten any questions from the, you got a couple already? Okay.
Yep. So I have one question here. The question is, do the systems that are built for event capacity, such as stadiums, remain on when not needed for capacity? The simple question is yes. The important thing to understand is that whether the in-building DAS system that's deployed within a stadium is dedicated for a particular carrier or for a neutral host, the immediate strategy that all operators plan is that that is now part of their network. So as you can tell, phase one, before a DAS is even deployed, macro cell sites are actually trying to bleed into these stadiums. So when a DAS is actually lit up, there's strong coordination between the actual DAS teams for the operators or integrators from an RF design perspective with the actual RAN teams that are managing the macro network. So the macro network, as a result, is detuned, or the coverage footprint is shrinked and isolated to improve macro level service, and the DAS remains on air. Now, obviously, peak utilization for the DASs within stadiums is strictly during when these stadiums are heavily used, whether there's an actual game going on or whether there's an actual concert. There was a comment earlier as far as making sure from a historic perspective that older buildings need to have some type of productive use. Well, the same business case can be applied towards newer buildings, making sure that they're actually applied to use. And there's a very strong benefit for operators to support that, knowing that at any given time, a particular stadium could be used for large mass events. So yeah, definitely the systems remain on. Any other questions?
This morning we talked about public safety and its requirements and interactions between the commercial carriers in the stadium environment. Can you talk about that?
Sure. No, that's a great question. First, I'm going to talk about, from an architecture perspective, what our equipment can support and typically what strategies have moved forward. Our equipment can support, in one physical remote, frequencies over all commercial bands in the United States from 700 megahertz to 2.7 gig. So that physical remote you see on that table over there supports all frequency bands. Now that's a distinct competitive advantage based off of size and scale. But within those frequency bands, 700 megahertz along with 800 megahertz is supported from a public safety perspective. And that's strictly talking about the equipment itself. Now, there's obviously, from an RF planning perspective, 700 commercial and along with 700 public safety. Our system has an architecture where a booster can be integrated in parallel with the design of an actual remote that's deployed, or it could be what we call daisy chain. It could be interconnected without having to pull additional fiber to that remote. And by doing so, we can support both 700 commercial and 700 public safety. Now, as far as choices of maintaining a system that's on a neutral host, that's all on a case-by-case basis. Our experience shows that in several large venues or arenas, there are architectures where a public safety network is separate from a neutral host environment, but we've seen several instances where we actually have a combined solution. And to date, all of our systems have been deployed, have been functional, and have supported both frequencies in both operators in both environments.
Well,
you're smiling, Don. I don't know if this is good.
No. This question is, can Brian give us an idea of the value, $ of the DAS system that was deployed by CommScope at Dallas Cowboys Stadium?
Well, whoever asked that question, I really love my job, and I'd like to keep my job. But, at a very high level, unfortunately, I can't disclose the size of these projects and size of the deployments. But I can definitely talk to people offline as far as experiences and guidelines as far as what we've done.
And earlier when we talked about the University of Michigan and its stadium, both the outdoor and the inside the stadium, but also the outdoor the surrounding because of their tailgating, is that a typical kind of?
Yes, that's a very valid question. A lot of the attention and focus, obviously, there's a lot of detail that's done to support the in-building part of a stadium, whether it's a perfectly enclosed stadium or an outdoor bowl type of environment. So when we are consulted to design any type of venue, we also look at covering outdoor parking lots. So our INV product set that's over there on the table is a low-part solution that's predominantly used for indoor, but we've done several stadium deployments where we have a combination of indoor and outdoor. Now, outdoor requires a lot of high power, more of a high power type of infrastructure. So by all means, yes, we definitely support in both environments.
Okay. I think that's fine. Thank you. Okay. All right.
So we'll take a couple minutes. If we could have the panelists for the third panel come up. Started with the last panel, the third and final panel today. I want to thank Brian for the lunchtime presentation. And we're going to have two moderators for this panel. Jeff Steinberg, who is a Deputy Chief of the Spectrum and Competition Policy Division in the Wireless Bureau here at the FCC, and Joanne Hovis, who spoke earlier this morning, who is the President of NATOA. So I'll turn it over to them.
Great. Thank you, Cecilia. Good afternoon, everyone. So for our third panel, I think in a way we're going to be going, really to the heart of what we came here for today, which is how we can all work together to bring the technologies that we heard about this morning to our communities. So during the next hour, we're going to learn about 3 communities that have successfully deployed outdoor DAS and small cell systems. And those are the City of Philadelphia, Paradise Valley, Arizona, and Charlotte, North Carolina. On this panel coming up, we're fortunate to have representatives of both the city governments and the companies that built the systems in each of these communities. They're going to tell us about how they started the process of deploying systems, the challenges they faced, how they worked to meet those challenges, and how the project turned out. We'll learn about the different paths that each community took due to its different circumstances and regulatory framework. And we're also going to learn about many things that they have in common that underlie the successful efforts that all of them undertook. What we're going to do is have the representatives talking about each community working together, the industry and the community representatives speaking in turn, and after we're through all the 3 communities, then we'll have time for questions. Again, as a reminder, we're here to discuss and to learn from the panelists' experiences in their communities. We're not here to discuss anybody's positions on regulatory issues, and we're not going to entertain questions about those issues. Once again, those of you on the web, you can send your questions to livequestions@fcc.gov. If you're in the hall, write your question on an index card and give it to one of our staff. We ask you to identify your name, who you represent, and which panelist or panelists you're addressing your question to. And again, please send in your questions anytime. We'll hold them till afterwards, but don't wait and forget about them. Give them to us when you're ready, and we'll get to them at the end of the panel. And now I'm going to turn the matters over to Joanne to introduce our first set of panelists.
Thank you, Jeff. Speaking about the deployment in the City of Philadelphia, we have 3 speakers, 1 speaker from the city and 2 from NextG Networks. They're private sector colleagues. From the city, we have Robert Sutton, the Divisional Deputy Solicitor for the City of Philadelphia. Robert heads the Intellectual Property Division of the city's Law Department, and his division is responsible for handling technology and telecommunications contracts for the city. Also provides legal support for public right-of-way management, cable television franchise oversight, public safety communications, and other wireless networks. And then from NextG, we have 2 speakers, Robert Delsman, who has held various executive and legal positions at NextG since joining as a senior director in 2002, and served as general counsel from 2009 to 2011. And with Robert is Christopher Sinclair, the senior director for network real estate for NextG. And Christopher joined NextG Networks in 2004 and is currently responsible for municipal interface in the Southeast, and worked in similar capacities before that with CSX Fiber Networks, On Fiber Communications, and Metrocom. So I believe that the gentlemen from NextG are going to begin, and then we'll hear from the city. Thanks.
Thank you very much. I'm delighted to have the opportunity to speak to this forum about the deployment in Philadelphia. If anyone had said in 2001 or 2002, when we began this effort at NextG, that we'd be here at an FCC forum discussing DAS as a mainstream deployment methodology, I think it would have been laughable. But NextG spent, I'm going to speak a little bit about the general context of this deployment that we began to approach the city with in 2007 with the specifics, and then my colleague, Mr. Sinclair, is going to address the specifics of that larger metropolitan deployment. At the time that NextG approached the city of Philadelphia, we were in the middle of the largest effort the company had ever made in DAS. We were deploying hundreds of nodes in the LA market, and at the same time a project in Boston that started out with 400, another project in the city of New York for 1,200, and then we approached Philadelphia for this project, all in the same year, initially beginning with 400 nodes. So it was a huge strain on the company's resources, and we were delighted, as I said, to speak about Philadelphia because it's an example of how a large-scale network deployment could take place and in what context in working with a city. It would not have been possible for us, suffice it to say, out of the box, to do this if every one of those 400 nodes in the city of Philadelphia had been subjected to a rigorous, some sort of zoning process or review that took a year or more with all kinds of various discretionary processes and hearings and that sort of thing. The only way it could be done is if there were a uniform approach to the deployment that allowed NextG to be treated the same as other utilities. And that's the effort that we've made for many, many years, that we'd like to open up discussion on here in this forum with NATOA and others. Very happy to hear the invitation for dialogue because ultimately we're a provider of telecommunications services and we ask to be treated as other telecommunications services providers by municipalities. We spoke to the city about the processes that are applied to wireline telecommunications carriers, and the city was receptive to that discussion. There were no special permits or zoning requirements in this instance, which is another element that contributed to the success simply by virtue of the fact that there was an antenna element incorporated into the network deployment. And finally, there was no exclusion, which is an important point to us, or special conditions for deployment in residential zones. We've heard a lot today about why DAS is so important for residential penetration, where capacity and use of smartphone devices and other devices that consume huge amounts of data is important in the places where people work and where they live, because often where they live is where they do a lot of their work these days. So with that, all of those conditions were met in Philadelphia, and when Christopher and I met with Robert Sutton and negotiated the agreement, it was a process that involved all of those elements contributing to success, but I'll let Christopher now detail precisely how that was done.
Thank you, Robert. Thank you, Robert. And Robert Sutton and I are going to interplay it since this is a collaborative discussion. So as part of the preparatory steps for a large-scale deployment in the city of Philadelphia, we actually started with filing and received our regulatory authorization from the Pennsylvania Public Utilities Commission. That was received in April of 2005. In parallel, we negotiated a pole attachment agreement with the electric utility. That was in May of 2005, and then a year later finalized the pole attachment agreement with the ILEC. So in terms of setting the framework for a successful large-scale greenfield deployment within the city. We also worked very closely with the utilities on finalizing the construction standards for the project-related equipment. Those were finalized in the spring of 2007. So those were the preparatory steps leading up to our actual filing of a formal application with the City of Philadelphia for a right-of-way use agreement and license, which actually would give us the opportunity to access municipal rights-of-way for the provision of telecommunication services. Just some brief background on the city in terms of statistics. It's a population of just over 1.5 million residents covering just over 135 square miles. It controls all of its rights-of-way, both limited access and non-limited access, and controls over 100,000 streetlight poles and traffic signal poles. So you've heard common themes today about pole infrastructure. NextG, like many others, prefers to be able to attach to existing poles where possible. And that was part of our strategy in approaching the city of Philadelphia. So we started, if I may have the, thank you. So as part of the municipal process, we filed a formal application with the City of Philadelphia Streets Department for a right-of-way use agreement and license. That was actually secured in April of 2007. It's a standardized document required by city code that outlines the general roles and responsibilities and legal obligations for placing and maintaining telecommunications facilities in the public rights of way, and it addresses the standard terms and conditions such as termination, security, insurance, indemnification, and so forth.
Let me break
Sure,
in here
sure.
just a minute to give you a little bit more background as to, this is Robert Sutton from the City of Philadelphia Law Department, and we had established this right-of-way use license and agreement as a basic administrative authorization to enter the right-of-way just a few years before NextG came to the city. It was the result of an effort to streamline the process of approving utilities and telecommunications companies to put their facilities under the streets and sidewalks. And it provided a way that the Streets Department could provide for an approval for the entry of new facilities without the necessity of having a specific city council ordinance authorizing every particular route. I should say that it was primarily motivated by the need to address congestion of underground utilities, and that because of the developments after the Telecom Act was passed in '96, the increasing number of telecommunications companies that sought to underground facilities, there was a great deal of congestion in the streets. It came to the point where several of the more narrow colonial era streets in Philadelphia had no room for other facilities, and it was necessary to do an overall review of that process. As a part of that, it included aerial facilities as well, although there had not been as much of a focus on aerial facilities, and to some extent the project that NextG came to the city with was somewhat new. We did have some previous experience in dealing with Metrocom, providing wireless service through the city, and we had worked out a pole use agreement for Metrocom to be able to use the city street lights as a way to gain access to the rights of way. We also had some experience with, where we're developing experience with Wireless Philadelphia also, which was a network that was established to provide wireless internet access throughout the city. And that continues, by the way, although it's been re-geared now for municipal use.
Thank you. So obviously, as a threshold matter, finalizing the right-of-way use agreement and license was critical to our being able to commence the overall RF engineering and some of the other sequential steps for a large greenfield deployment. The city, thank you. So because of our regulatory authorization by the state PUC, the city treats NextG as it does any other utility deploying its facilities in the public rights of way. And due to some rather extended sessions with city staff and the streets department and elsewhere, the city became quite familiar with the uniformity of our installations, particularly attaching to third-party utility infrastructure in the public rights of way. This greatly expedited our productivity and progress within the city, and we consider that to be a model for replication in jurisdictions across the country for expansive greenfield builds and to further a broadband deployment.
When NextG came to the city, one of the things that we discussed a great deal was the available resources within the city and the nature of the aerial and underground facilities. The City of Philadelphia has had a policy for quite a few decades that there would be no new aerial facilities, aerial wires in the center city area of Philadelphia, and also in some areas of West Philadelphia where the University of Pennsylvania and Drexel universities have their campus. And so the facilities that were available for NextG to use did not include the utility poles in those areas of the city. And they needed to rely on the city government to work out a pole use agreement that would allow them to put facilities on the city streetlights. We had some problems with this because we realized that the city streetlight poles were not designed necessarily to take the increased burden of the NextG facilities, even though they were not particularly large or particularly heavy. However, streetlights, although they may look very stable and sturdy, are not necessarily designed to take the wind loads that would be created with the facilities at a particular height. And so we needed to work out a way that a number of streetlights could be replaced. And one of the elements of the agreement that we worked out with NextG was that NextG agreed to provide replacement facilities, replacement poles for the city streetlights to the specifications of the City of Philadelphia. And that was done for a large number, of, not all, of the streetlight poles that were decided to be used.
So to Mr. Sutton's first point, because of the aging infrastructure and congested rights-of-way in a very old and historic city, one of the strategic decisions that NextG made going into and accepting the large-scale deployment opportunity was to use the services of a turnkey fiber provider who already had assets and relationships in the city and with the city. So that really helped facilitate our progress in actually rolling out the deployment. On the matter of the pole use agreement and so forth, we actually engaged the city very early and at the staff level through the Streets Department Bureau of Street Lighting. We actually met with them quite a number of times to understand their processes and build up those working relationships to establish those lines of communication. They were extremely helpful and continue to be to today in identifying the pole selection criteria, the construction standards, valuable input on potential obstacles and challenges in the rights-of-way, such as street widening, realignment, resurfacing, pole replacement, capital improvement projects, and so forth. So within the scope of the original deployment, we used 37 city-owned poles. We're now up to 54 to include both streetlight and traffic safety poles. And at the end of our sub-presentation, if you will, there are some photographs that I can certainly go through. But because of the limitation, and I think a general reluctance to entertain applications for new poles in the public rights-of-way, this was a classic win-win for mutual benefit, because as we were replacing poles of an older vintage with that of a modern vintage, we actually worked with the Streets Department to consolidate existing poles of duplicative function on the same street corner. So whereas there may have been a traffic signal pole and a streetlight pole and a traffic sign pole, all of those were then consolidated into one pole, obviously securing valuable real estate on the street corner. So that was definitely a model that we achieved, and to great success, and it was certainly continues to be replicated today.
So I'd like to just review, as far as the city's authorizations for NextG to provide for its facilities in the city, there were 3 levels of agreement, I would say. First was the overall right-of-way use licensing agreement that Chris Sinclair mentioned first, which is the authorization to be in the right-of-way generally throughout the city and to have their facilities on the poles of the electric utility, or to the extent that it may have been used on the ILEC. Second, the specific pole use agreement with the city for use of city facilities, which in this case was the streetlight poles. And then third, there are also permits that are provided at the time of actual deployment or in preparation for actual deployment, there would be specific permits issued to NextG for the right for particular locations to be used. And that's in response to engineering specifications that are provided for each particular site to the city. I should also add that there are other permits that would also be required when NextG was working to do the actual deployment and installation. It used a subcontractor, which actually had done a lot of work with the city before. And I presume that NextG entered into the contract with them to do the actual installation work, because this particular contractor had already built up a good relationship with the city over a long period of time and was very familiar with city processes. And that contractor also, of course, needed to get specific permits for excavation when it was required to replace a particular pole, and they would need to dig to provide for the foundations. That would be subject to an excavation permit that would be obtained by the subcontractor.
Correct. Thank you. So as a part of our deployment, a number of the nodes actually were contemplated within designated historic districts. So we met and conferred with the Philadelphia Historic Commission. There were actually 17 sites in the initial deployment primarily on city-owned poles. We worked on an administrative process to allow this type of deployment within the public rights-of-way, again, on city-owned poles. The Historic Commission naturally is chartered with preserving the city's strong ethic of historic preservation and aesthetic conservation. And this ended up being a type of deployment that they like to encourage, as opposed to rooftop macro sites, if you will, on, say, a 2- or 3-story building that would detract from the overall historic theme and character of a neighborhood.
Let me break in here a little bit further. I did have a discussion with those individuals at the Historical Commission that worked on the NextG application, and what they had indicated to me was that it was handled at the staff level because it did seem to be consistent with the policy of the Historical Commission. However, it was very much based on specific site, specific locations, and it could be a different outcome for a different site. Ordinarily, the Historical Commission is primarily interested in the integrity of historic buildings that are located in historic districts or that may be individually certified as historic. This is a little bit different situation when the facilities were not actually to be installed on the buildings, but in the area of the district. And even in that case, the Historical Commission does have authority to review applications for facilities in the right-of-way that may be out of compliance and would detract from the historic integrity of the neighborhood. It was judged that in these locations, these particular 17 locations, that there was not a problem with that, that actually the scale of the NextG equipment and the particular locations, frequently in areas where there was was described to me as a lush tree canopy, where there would be a lot of trees, and these facilities would be in areas where there already were poles and some signage and so forth, that it was not considered to be a introduction of a facility that would be detracting to the historic character of the neighborhood.
Thank you. So other than that, there is no zoning or other discretionary form of review or consent required for our installations, whether on a city-owned pole or on a utility pole, again, all in the public right-of-way. There was a customary permitting process, as Mr. Sutton alluded to, in particular for our proposed attachment to a city-owned pole. We went through the very similar processes with the Historic Commission, a formal application, engineering review, site survey, and so forth, in-field collaboration, a very predictable timeline and process path, which did lead to, again, a mutual benefit pole replacement. I just, over the past 5 years, so that was our initial deployment. It was on air in July of 2009, I believe. That was for an initial operator, a new entrant into the Philadelphia marketplace. And I'll get to the slides here in just a quick minute. But I just wanted to reiterate that we consider this to be a very successful model for deployment. And we certainly appreciate the city's efforts in getting to know NextG and this type of technology. Telecommunications is still very much a people business, and for those very few instances when we did receive calls from the general public or from staff or from elected representatives, we were most responsive. And I think that there's been a general support and encouragement for this type of installation in the city in the public rights-of-way, and we certainly appreciate the cooperation that the city has offered over our working relationship.
I should say that the relationship has not been a perfect relationship. There have been problems that have come up, but there are, as it's reported to me by the inspectors in the Streets Department, to be the types of problems that appear from time to time when work is done in the right-of-way and not extraordinary and not related to the particular type of facilities that NextG is putting in place. There has not been any kind of public outcry in relation to any dangers of the antennas, or there have been some inquiries about what the new equipment was, but it has not caused any kind of a problem that we have become aware of. What we have recognized is that it's important for the regulatory bodies, the Streets Department in our case, to become aware of the whole nature, the whole package of changes that would be introduced in an area because of the antenna, so that it's not purely an aerial facility. It's not only the antennas that are put up by the street light or on the electric pole, but there are attachments to underground facilities. There will be some excavation work, and it's important to remember that frequently distributed antenna systems are put in place in areas where there is a fair amount of congestion, and that means congestion underground as well. For example, one of the areas where there was a pole replacement was at Love Park, a public square right across the street from City Hall and the Municipal Services Building, where many of the meetings that we had with NextG took place. And it turned out that the nature of the underground facilities that were already installed required that the foundation of the new pole be not as deep as was originally planned and would have to be extended out a little bit further. And there was a concentration of facilities in that location that made that a little bit tricky. And it actually extended further towards the corner where there were some ADA ramps that had to be worked on. And so there's an issue of the ramifications of the foundations, and it is important to get the whole picture and to be very site-specific.
Indeed. So, having said all that pictorially, so this is a map of the city jurisdictional footprint, again, 135 square miles, in which I think we're deployed in just over 100 square miles. This was for the initial deployment, which we started in 2008 and then brought online July of 2009. 401 nodes. Again, this is a greenfield build for a new entrant into the Philadelphia marketplace. They were an early adopter of DAS because they wanted to be able to target repeatedly with a great deal of precision those high traffic areas. And as you'll notice, that the concentration there in Center City, University City, and other neighborhoods. And then they use the macro cells in the lower traffic areas. Sort of fast forward, we've completed 6 subsequent phases for the initial operator, 2 phases for 2 additional operators, and we're just in the process of commencing engineering for a 4th operator. So we're almost at 500 nodes just within the city of Philadelphia and just over 1,000 in the greater metropolitan Philadelphia area. So just to give you a sense as to some of our representative installations within the city, this is a primary utility pole. You can see the antenna mounted at the top of the pole, actually atop a pole extension bracket, and then the equipment shroud containing the node electronics is actually lower on the pole there, just above the pedestrian space. This is likewise a utility pole, but a side view of the actual equipment shroud, and in this case in a residential neighborhood. This is a primary pole with 3 sectorized antennas at the top, again to customize a small cell solution for a specific RF coverage objective. This is in the proximity of Temple University, as you can see by the banner. This is a secondary electric utility pole, obviously with the presence of the secondary power. Otherwise, it's a beautiful bare pole. Again, the antenna is mounted at the top of the pole with the equipment shroud lower. Again, all existing infrastructure. In terms of city-owned light poles, this is a replaced city-owned streetlight pole. That's the beautiful Philadelphia City Hall in the background. The antennas are mounted just below the top of the pole. There are 3 panel antennas, and then the equipment shroud is mounted just below the antennas. Again, our network is designed for co-location either within on the pole with the existing equipment and or along the fiber-fed network. This is another variation of a installation atop a city-owned streetlight pole. Again, this is a 3-panel sectorized configuration. Again, the City Hall is featured in the background. This is a city-owned streetlight pole in a designated historic district. Very similar equipment configuration than those that have been previously presented. This is a side view, again in a historic district. This is a traffic signal pole. This is just north of the Philadelphia City Hall, which you can see in the distant background. The historic Philadelphia Daily News building is there between the
Inquirer.
The Inquirer, okay.
The Inquirer building.
On the border of a historic district. And then lastly, this is another installation on a city-owned traffic signal pole, again, just to demonstrate how the equipment blends in with the streetscape.
Well, thank you, Christopher. Again, we're delighted to have had this opportunity to, in the context of this forum at the FCC, discuss the elements that NextG considers made possible the success in Philadelphia, which are that the city accepted our authority as a telecommunications provider from the PUC and the state of Philadelphia, that they had a defined permitting process in place that treated us on a non-discriminatory and equivalent basis to wireline providers, that there were no special regulations imposed simply by virtue of the fact that an antenna was incorporated as an element in the networks, and that there were no restrictions or special zoning requirements for deployment in residential zones of the city. And we would welcome the opportunity to continue the dialogue for understanding with NATOA how we can expand this sort of background condition of creation of conditions that could further the success of DAS deployments throughout the U.S.
Thank you very much.
Thank you.
It's very interesting. Our next presentation is one of my favorites, actually. And I don't want to steal anybody's thunder here. I'll just say by way of introduction, Paradise Valley, Arizona is a small, upscale residential community with unique needs and constraints. And I think you'll be very interested to hear how Crown Castle and the local government work together within these constraints to bring both residents and visitors the mobile and broadband services that they want and need. Our two panelists here, first we have Mary Hamway, who is the Vice Mayor of the town of Paradise Valley. Mary has been on the Paradise Valley Town Council for 8 years, and she's currently serving her second term as Vice Mayor. During her time serving the community, Mary has worked on many projects, including public-private partnership to renovate a school athletic field, as well as major resort development projects. She also serves on the board of directors for the Scottsdale Convention and Visitors Bureau. And outside of her public service, Mary has extensive experience in information technology, specializing in database design, operating systems management, document imaging, and applicant workflow design. Stephen Garcia introduced himself this morning, but just to review and expand a little bit, he is the Senior Manager of Land Use External Affairs at Crown Castle. In that capacity, he is responsible for managing all acquisition of permits and entitlements for DAS in the western United States. And in the past 2 years, he successfully secured entitlements for more than 400 DAS facilities in Arizona, Colorado, and California. Prior to joining Crown Castle, he worked for 15 years in planning, public rights-of-way, and government affairs for AT&T Wireless, Sprint PCS, Singular, and New Path Networks. And with that, Mary and Stephen.
Well, thank you. I'd like to take this opportunity just to introduce a few background facts about Paradise Valley. One, what we heard earlier today on panel 1 and in this panel today was about existing verticality. We had quite a different experience in Paradise Valley. As you know, that western part of the United States, many of those areas have no existing verticality. And in this particular case, Paradise Valley had no above-ground infrastructure for electrical lines or other types of typical installations. So in this case, we'll be sharing with you ways we think our collaborative efforts with the town of Paradise Valley created a new paradigm for the town to provide infrastructure, DAS infrastructure, at the same time balancing the needs of the community. If you could, there we go, thanks. So Crown Castle DAS, a case study, Paradise Valley. Just real quickly, Paradise Valley, Arizona is a premier low-density residential community, has an area totaling 16 square miles, just below 13,000 residents, and approximately 5,500 housing units. A couple of facts that I didn't include up there. At the time of our application, there were just 3 non-residentially zoned parcels and 4 existing macro sites. There have been plans, or the city did approve 27 pre-approved macro facility locations, but again, just 4 had been utilized by carriers up until this time. Some of the objectives for Paradise Valley: deliver high-quality broadband service, work collaboratively with the town staff, maintain the town's development standards, and proactive public outreach. I would say that the bottom corner, public proactive outreach, was probably essential to the success we have and enjoyed in Paradise Valley. There was great respect between both organizations, Crown Castle and the town, in trying to reach out to the public. Sure.
One of the things that we did, all our zoning is done through something we call a special use permit. And before we get started on a special use permit, the council develops a statement of direction. And the first one we'd ever done was actually with Crown Castle. But the purpose of it is to define up front what the council would agree to, because we're the governing body, and in past, basically developers or applicants would come in and they'd kind of spend a couple of years guessing what would make us happy. And we decided that that was unfair and that we needed a way to say up front what we would agree to. Now, this statement of direction is not binding. It doesn't grant entitlements, but it is a gentleman's agreement, and it does define for the community, for the Planning Commission, and for everyone involved what the direction would go. So, for example, in the statement of direction, we defined what our goal was. Our goal was to improve cell coverage. We had kind of become the laughing stock of the metro area. We're nestled between Phoenix and Scottsdale, and we have no commercial buildings. We have no verticality, as Stephen said. We have spent millions of dollars undergrounding our 69 kV utility poles. We also have a dark sky ordinance, so we have virtually no street lights at all, certainly in our residential areas. The only street lights there are on, we have 2 major roads that go through that connect Scottsdale and Phoenix, and you drive through Paradise Valley. So there are lights on those roads. But And we also have extensive view corridors. We take that, someone's view of a mountain or it's really just mountains, we wouldn't want to do anything that would interfere with that. So this statement of direction basically defined the goal to improve cell coverage. We defined the process that we would go through, and then we also defined how final approval would occur. So if there was a problem, who had final say, and that would be the council. So the council took a very active and strong leadership role throughout this whole process.
Yeah, it's really critical to point out and highlight the statement of direction. I think without the statement of direction, we encounter what we find many other locations where a discretionary permit is required, but there are no parameters. There's no definition of what is desired by the community, and it simply is left up to the mass of folks that end up at the community meetings. And once the statement of direction was defined and approved and adopted by the council, it made everyone's job much easier. And I'd say for a timeline for 42 new locations, that 6-month timeline was fair and reasonable given the circumstances that we were involved with. So system overview, we have 42 new node locations, 169,000 linear feet of fiber, or just shy of 32 miles, and one hub constructed on the town property. The 3 circles there identify the primary concentrations of nodes. In the north, we had 25 node locations. In the south, we had 10, and to the east, we had 7 total. Again, a total of 42 node locations spread across and strategically located to mitigate the service issues for our client. Flexible options. So we ended up with 37 faux cacti, 3 street lights that were available within the polygons that I just shared with you, and just 2 traffic signal locations. So again, we had to be flexible. We had to work collaboratively with the community, with the town council, in order to identify what and how that would look. We certainly had experience with faux cacti in other parts of that Arizona desert, but we didn't have the same sort of criteria defined as we did in Paradise Valley. Paradise Valley took a hands-on approach to meeting with us, visiting other locations that we had approved in the surrounding areas, and I think it was that hands-on approach that really made a difference in accelerating the decision-making process. One of the things, in addition to providing design options, we also installed a temporary facility at the town hall, and much to our surprise and many other people, once that facility was installed, nobody realized that it was a faux cactus. Why DAS for Paradise Valley? And I apologize, but I'm going to need to read these carefully over. The DAS brought enhanced wireless service to the community and preserved the town's single-family character. So again, it's a single-family residential community, low density. That was critical to getting this project off the ground. DAS provided pinpointed coverage in the neighborhoods. That was also critical. As I mentioned earlier to you, there are only 3 non-residentially zoned properties in the entire town of Paradise Valley, and that's within 16 square miles. The architecture of DAS allowed for creativity and flexibility, again, essential to locating it in the public rights-of-way, which in many cases, as all of you know, is very limited and unpredictable. So without a very small footprint, without the ability to conceal the antennas and equipment within the faux cacti, we would have had a really difficult, if not impossible, time installing these facilities. So a couple of typical node profiles. Again, in residential, within 40 to 150 feet of most of the homes in that community, we're able to install, with the work with the town, 42 node locations. And this particular example, you can see the backdrop is a single-family residential home, a 1-acre lot, and the star indicates the location of that facility. And again, you can see the surrounding homes that face that facility. So the hands-on approach with the town really made a difference in identifying what the best location would be or could be. Another node location, again, along the rights-of-way. You can see the homes on 3 sides of that facility. I just can't emphasize enough that without the hands-on approach, this could not have been done. Ultimately, with the statement of direction defining that the council had sole authority to approve those locations, we could have been in one of those situations where it's a majority or vocal minority that defines where and how these things get done. And in this case, it wasn't.
One of the things the statement of direction did was it gave the Planning Commission basically the job to go out and to cite these faux cactus with Crown Castle. Obviously, we were looking for efficiency and good communications, but within that, you can kind of tweak where these things go. So each planning commissioner took about 6 of these sites and went out and worked with the neighborhood. I think we had over 16 public meetings. Is that
that's right.
16 public meetings? And it was interesting. When it was actually New Path who came to us, and now they are owned by Crown Castle. But when they came to us, probably, I don't know, in 2009, maybe early, I think it was 2009, we balked as a community. We really kind of fought. We didn't really fight them. We just didn't give them time on our agenda. So we kind of took that deliberate government approach of kind of delaying talking about it. You know, we'd put them on the agenda and they'd talk and we'd say we need more information. And so we just really weren't that excited about this technology because at the time we thought it was traditional kind of put on a light post or put it on a stop sign, and we'd seen the picture images of the stop sign with this big honking thing on top of that, and we knew we did not want that. This is a community that deals completely in aesthetics. You know, these are high-end homes. Every home is on an acre, and it's a very affluent community. And while the demand for better cell coverage was increasing, we had to find this balance. So it wasn't until we started talking about the faux cactus that we began to see, well, maybe this will work in our community. And then once we started rolling, they had 3 cacti installed in Scottsdale from 3 different manufacturers. I think one was from New Jersey, one from Tucson, and I'm not sure where the other one was. And we went out and looked at the quality of the faux cacti, and you know, we've been looking at these for our whole life, and they're beautiful, iconic structures. So the one from New Jersey got immediately eliminated. You could tell they'd never really seen a real saguaro. But the one from Tucson was gorgeous, and in fact, it's so interesting. People will run by these and not even know that, you know, jog by them and not even know they're a real saguaro. I mean, a fake saguaro. I had a phone call from a friend who was jogging, and she called me and she said I needed to let the police know that there were bees in a cactus that she was running by, because we're always worried about Africanized bees. And so when you're jogging outside and you hear bees, you immediately run the other way. So she called me and I called the police, and I said, well, where was this cactus? And she gave us the location. Well, it was one of the faux cactus. And the humming, the bee sound was the humming from the technology. So she didn't even realize this was a faux cactus. So we made a good selection in going with a vendor from Tucson who really knew what they were doing. And it was interesting. I think I started talking about this, that you could predict before we started, out of the 46 nodes, 50% were going to go in, no problem, no hassle. And then another 20% were going to require some tweaking, moving around. And then another 20%, you know, were going to bring out people and they wanted to know what was going on. But really only about 10%, about 4 sites, required what I would call intensive involvement by myself. I was kind of the designated go out and make these people happy kind of elected official. And we really, out of the 4, I would say only 1 was really unhappy. We had to cart one lady off to jail, but short of that, you know, we did pretty well. And I say that laughingly because she absolutely didn't want it, but the town had done everything it needed to do. We had noticed, we had done everything, we'd worked with the community, and she was just not going to have that thing near her home. And she did it for the drama. She was hoping to get attention. She was hoping that the attention that being called off to jail would turn this whole thing around. And of course, none of that happened. It was a non-story. And she was very disappointed by all of that because, you know, we had done everything we could do and should do. Our town always goes above and beyond noticing. If the state requires 200 feet, we do 1,000 feet. If we require, you know, 2 public meetings, we'll have 5 public meetings. So our community, I'm very proud of that. We always go above and beyond. And one of the other things we did is we hired an outside consultant to answer any questions. So if anyone had any questions about health issues or anything else, there's a tremendous distrust of government in the western part of the United States. So we wanted to make sure that we offered a third-party objective consultant to answer any of those questions. So I think that the reason it worked is because the government did take an active role, but we understood that this had to fit in our community. We had just done a visioning project. We know who we are. We know what we want to do, and we know that we don't want commercial. We want to maintain our low-density lifestyle, and aesthetics and view corridors are our primary concern. And so that's why the faux cactus really worked in our community.
All right. Thank you.
Thank you. A very interesting story with some surprise twists as well. Our third presentation of a deployment in another community comes to us from Charlotte, North Carolina, and we have a speaker here with us in person and also someone on the line with us. So let me start with Carmen Rajamani, who is here with us in person. And Carmen is a regional director for the South Plains and Southeast regions for DAS Strategic Relations for American Tower. She and her team negotiate agreements with pole owners, fiber providers, municipalities, and they also perform community outreach. Carmen has extensive experience in zoning, permitting, tower development, and site acquisition nationwide. She was American Tower Corporation's National Zoning Manager before she joined ATC Outdoor DAS. And then joining us also on the phone to provide part of this case study and story is Kruti Desai, the engineer and right-of-way use manager for the city of Charlotte, North Carolina in the Department of Transportation. And Kruti is a licensed professional engineer and is right-of-way section manager in the DOT in Charlotte. Kruti worked as an engineer for 11 years with the Charlotte City Engineering Department as a project manager for transportation projects and spent 5 years with the North Carolina Department of Transportation. Please go ahead.
Good afternoon. I'm Carmen Rajamani, and thank you very much for the opportunity. That the city and American Tower really feel that our downtown Charlotte deployment has been very successful, and you know, as the person who was there to spearhead it, I'm actually very proud of it.
Forgive me for the interruption.
Yes, do I need to get closer? Yeah. Oh, I keep hearing this humming. Okay. All right. So let's see, to start our presentation, let's see if here we go. So this is just a quick overview of our deployment. It is there in downtown Charlotte. You'll see a beautiful shot of it there. It consists of 33 nodes. The system is deployed. Of the 33 nodes, it consists of 16 that are on existing metal decorative streetlights. There are 15 nodes that are on the traditional wooden utility poles, and then 2 nodes where American Tower placed them in the right-of-way that are similar in design to the metal pole that matches aesthetically with something that the city already has deployed in the right-of-way. Something, you know, our project, I think, echoes some elements of the 2 other municipalities that we've heard from this afternoon. That one key to American Tower's success, I think, is that the city of Charlotte has, a right-of-way department. And they handle public utilities as separate from the traditional zoning and permitting process. So with that, American Tower ATC Outdoor DAS is a licensed public utility in the state of North Carolina, in addition to many other states. But for Charlotte, we are in North Carolina. And because of that, it took us out of the traditional macro site zoning and permitting process. The city has a very extensive, very well thought out, thoughtful right-of-way process with a fixed timeline, applications, permitting process, siting process. They were with us, I think, as partners really throughout the whole build. And I think that that was really part of the success of our build. You can see that out of the 33 nodes, we only installed 2 new locations, 2 new node poles, and that was very intentional. That with other DAS builds, you'll see there are a number of new poles that need to be placed. The city was very clear with us that their objective was to maintain the aesthetics of the right-of-way. Where, you'll see in a couple of slides where we built them, we built part of our system, half of it essentially, was in the central business district, where streetscape is very valuable. So the option of placing new poles was not an option. So we did use the existing facilities that are there, and again, I think that's part of the attractiveness of DAS, is that you use what's existing. The other thing is that the city was very interested in is that we have a committed carrier, that this is not speculative, and that, again, we built a neutral host system. ATC Outdoor DAS is a neutral host provider. So the system that we built for the 33 nodes, we did build for multi-tenant, and that was very important to the city, that they didn't want the city to look like a bunch of a pincushion, that there are nodes everywhere because they're servicing different carriers. So we were very deliberative there. So in addition to the 33 nodes, there are almost 9 miles of fiber. That we do have a hub site, as all DAS deployments do, or I think it's been called the head end in some of our other earlier panels. And so there, because of like uses, we were very fortunate that our pole owner actually has an electrical substation that we were able to utilize. So this is just a brief snapshot of the location. You can see that we had two. There are 2 sort of areas of where we built the little triangles and circles. Note where the node poles are. The triangles are streetlight locations. The circles are the utility poles. And then the red line is where we used existing underground conduit. And the green is where there was an existing aerial fiber path that we followed. So you can see that essentially I think of it as 2 areas. The northern part of the map shows what is the central business district, and roughly half the nodes are located there. And then in the southern portion of the map is a mixed use area. It is residential, certainly, with some small commercial and retail locations, and including a hospital and some universities. One thing you'll see with the map is, why are there 2 distinct areas? That Charlotte actually has a number of macro sites. And even with the macro sites, and actually if we go back to the previous slide, you'll see there's a tower there in the photo in downtown. So even, one thing to stress is that with this build, and I think with DAS, many DAS builds, is that it is not a replacement for macro sites, that it builds in conjunction with. And so that was very much the case with our downtown build, that even with all of the macro sites, that there still was the need for a DAS system. Just to give you a little bit of a timeline here, that we did start with we had a very collaborative relationship with the city. We reached out to them early 2009 and had an education process. The city was very involved. At the same time, we were negotiating our pole attachment agreement that for the street lights in Charlotte are owned by a third party. And so we needed to negotiate an agreement with the pole owner. Roughly in 2010, we started construction. That took about 6 months. That we did have, as you're going in, existing conduit. There are some blockages or things, need some adjustment. So we had some issues to work through there. And then in 2011, early in 2011, late 2010, it was deployed. So it's been up and running for about a year. So next we go through some sample installations that, as I mentioned, our poles really were of two different kinds. And so this shows where we installed the node equipment on existing poles, and we had a variety of different streetlights. So you'll see that we did use a short Omni antenna here. These are 2 feet. It is pole top mounted. All of our equipment is mounted at the top of the pole. Also, the city did not want ground furniture. So all of our equipment, the control panel is mounted on the face of the pole as well. And then our pole owner required a meter box for the electrical. And you'll also see that we were very particular in wanting to keep the aesthetics of the build, so that as people walk by, it wouldn't be jumping out at them. And so to that, we were very particular about painting to match. And you think, oh, it's, black streetlight pole, black is black. There are many variations of black and white and green, especially when your poles have faded a little bit. So I felt like at some point we were a little DIY with sponge painting and that sort of thing, but we took that very seriously on painting to match. So just to give you a little flavor there of those kinds of streetlights. And then we have another one here to the left. This is actually one of the poles that American Tower placed in the right-of-way. And as you can see, very streamlined, very similar to the street light, the metal poles that the city already had installed, again with the antenna installed at the top and the control box there on the side. And then here is an example of the wooden pole that we did that we didn't place, that we utilized, that was existing. And here we chose specifically for the equipment utility gray. We did take a survey of the existing attachments to other wooden utility poles, and you can see, well, I'm not sure if you can see from this photo, but a number of the wooden poles are installed in older residential, very nice neighborhoods. And so we wanted to be, again, very considerate of the aesthetics, and so we did deliberately choose the gray because we wanted it to match the other equipment that it was already in the right-of-way. And so just to wrap up, to give you some, these are what the city, Crudy, and I think are the keys to success of our build. And again, I think something that's been echoed here on the panel is really, and they are in order of preference, of priority, is the collaborative relationship with the municipality. If we did not have this relationship with the city of Charlotte and their willingness to work with us at every step of the deployment, it would not have been as successful as it has been. And so with that, Crudy, would you like to talk a little bit about the process that the city requires as part of your permitting?
Sure. At the time that ATC approached the city, Charlotte had already put in place a new utility ordinance that was adopted in 2007, and it had several requirements. First being a master permit requirement, where the utility had to get a business license from the state of North Carolina. They also had to have a certificate of authority issued by the North Carolina Secretary of State and a certificate of public convenience and necessity issued by North Carolina's Utilities Commission. And there's an annual fee required with this master permit as well. Also, the utility companies had to provide a list of contractors, and those contractors had to have a valid and current license to do business in the state of North Carolina. The contractors' employees have to have excavation certifications as well, and the city can provide training on those if needed. And then after the master permit is approved, then we can have separate permit applications for each installation, and the utility companies have to ensure that the contractors are listed on here and have copies of the permits. And through that process, there's a plan review process that typically takes less than 20 days to approve the permits, and that's a lot of collaboration with our staff, being out in the field and looking through plans and any conflicts. And after that permit is approved, the utility must notify the city 48 hours before actually starting work with our inspection staff. And then, and that's a long process as well. And then as the project is completed, we may require as-built plans. So that's just kind of a short version of our process.
And as you can see from the City of Charlotte's process, I mean, it is laid out. There is timeline associated with it. There is definitive begin and end. And coming from the tower side, where things, especially if you're not in an administrative process, you're going through a public hearing process where things are a little bit more loose. Frankly, from my perspective, as a business person, having that definitive timeline and process, and that the city treated us as any other public utility. They were not thrown off by the antenna. Was very refreshing, to be frank. So something else that the municipality, as I mentioned, was very concerned about were the aesthetics, that we showed them. These are the types of antennas. These are the types of control boxes, or the shroud or not a shroud. And they worked very closely with us on the way that the node equipment should be placed and what it should look like. Also the node locations that we did quite a few drive-arounds with Crudy and her team. We went in, of course, with my RF engineers with a circle around downtown Charlotte and a bunch of dots for poles that were our preference. But they were very thoughtful with us about, no, that actually can't go there, but it could go here. And so again, that collaboration was really key. And then lastly, resident notification, that we've been very fortunate that I think it's the placement of the build, I think it's the way that the node looks, that we did not get public outcry that you might hear about for other DAS systems. So that was, I think, fortunate for us. But we were very, very clear with residents when they did inquire. That we, at American Tower, we have a process for handling those inquiries. And then the city also, again, with every other construction project, has a process that we followed to let residents have notice of, this is the work that you're going to see, or these are, why guys might be placing fiber in your neighborhood. Second, we have, as I mentioned, we have a pole owner that actually owns the streetlights downtown. And so we had a very straightforward relationship with them. As I mentioned, we also have our hub located on their property. So it was very clear, this is what we wanted to propose. They gave us timelines and turned things around. So that was good as well. And then lastly, I think that our thoughtfulness in providing a good design that was accepted, by our customer for whom we're building the system, but also the municipality who has to live with our nodes, and then the pole owner who has these attachments to their infrastructure. I think that because we did a lot of homework up front on the equipment, the way that it would look, the locations, and then making sure that it did look like a seamless, one piece of equipment on a pole, I think that good design helped move the process along. We weren't spending time, arguing about those sorts of things. And that's all. Crudy, I don't know, do you have any other closing thoughts on our successes in Charlotte?
Just the collaboration between the pole owner and the city and the relationship they had with ATC, I think it was just a lot of good coordination that was done to make it a success.
Okay, well, thank you.
All right, well, we don't have any questions coming in yet, but we're certainly prepared to ask a few, and maybe I'll kick that off. And I know, Mary, you told us in a little bit of detail about your public meetings and such, and Carmen, you spoke a little bit about the notification, but I wonder if the panelists could elaborate a little more on what you did to educate and to involve the public in the process. To what extent this came from the municipal government, to what extent from the private sector participants, and and particularly at the early stages, as well as the notification that we're going to work here.
Sure. So primarily within the streets department. So in the event that there were inquiries either from citizenry, from fellow staff, or even elected representatives, most likely those calls would be forwarded to the streets department so they understood what we were constructing, why we were constructing, the various authorizations. They were familiar with our project. They were familiar with the key personnel with whom they could communicate for any given issue and so forth. Also, we use door hangers that are hung several days in advance of deployment within a certain neighborhood, that with a telephone number for 24/7 contact. So when calls would come in, most likely 9 times out of 10, it's a result of curiosity. I just returned home, there's a door hanger, should I be concerned, how will this affect me? Our project staff was authorized to identify our endeavors within that certain area, within the date, and again, 9 times out of 10, that would suffice. If things were escalated, we have a protocol within our project office to address those issues as needed. And that was a successful model for us.
I don't know if anyone wants to add anything else.
In Charlotte, that we also utilize door hangers, and again, that's part of the city's process to require not only us, but all folks that are working in the right of way to hang notification door hanger a couple of days in advance before our crews are going out there. Additionally, the city, as part of after our initial deployment of our system, they have a utility code, and in there they made some adjustments for DAS, and one of them was resident notification. And it is, I believe it is truly, we have the obligation to go out proactively. That's part of American Tower's process, but it was written within the city's code where we are placing new poles in residential locations that are not on major thoroughfares, and there's some other requirements. But the city did change their code to address resident notification and be a little more clear in, I guess, in case of, future concern.
I was just going to say, we did all of ours through mail, and then everything was posted on our website. So if you had a particular question about node number 33, you could go to the website, pull up everything was digitized and scanned, and everything was very available for anyone to see.
Well, the questions are flowing in now. And the first one I have is for NextG, I think for Christopher probably, with regard to the Philadelphia deployment. And it's a two-part question. Are you using the same license frequencies as the wireless operators? If yes, are there interference issues, and how are you coordinating with wireless operators in terms of RF dimensioning and planning?
Well, NextG as a carrier's carrier specifically engineered, designed, and constructed the various phases of our network. So we don't own or control any spectrum per se. So that spectrum is exclusive to our operator. So ostensibly there shouldn't be any interference because of that exclusivity. In terms of other interference and so forth, as that may arise, then our technical staff would certainly work with that. But to my knowledge, that has not been an issue.
Thanks.
This is actually, it looks like it follows up to some extent on some of the discussion on the second panel, but for your systems, do the systems have any public safety functions, and if so, what was turned on? And also, is the system a neutral DAS with support for 3 to 4 providers?
Yes. Again, Stephen Garcia for Crown Castle DAS. The system is a neutral host, as the other panelists have described. It's a multi-carrier. And was provisioned and permitted for future growth. There are no public safety frequencies currently on the network. However, we had preliminary discussions with the town, but that remains to be seen as to when that may occur.
Either of the others want to address, I think you've addressed the neutral host part, but the public safety piece of it?
It was not part of our project.
Okay.
And in Philadelphia, public safety uses separate 800 megahertz channels doesn't use the regular providers for mobile phone service.
I will say in response to that, though, that the word DAS is quite generic in the sense that some companies do what's called neutral host, as has been indicated. Others, such as NextG, doesn't, because in our experience, attempting to come up with a single design that 5 carriers can agree to in advance, all of those carriers wanting 3 or 4 bands, that means 3 or 4 amplifiers and very large equipment, makes it, in our view, in our experience, very difficult to plan for a single site that would accommodate numbers of carriers. So we only have constructed in response to a particular order from a particular customer, and when we get another customer order, we'll add that equipment and that customer to the same fiber backbone design, but not necessarily. If possible, we'll co-locate in the same equipment boxes, but not necessarily.
Maybe just add one more clarification regarding public safety. I think many of you know that most of the town's public safety personnel are on existing wireless networks. So with the enhanced service that the DAS systems provide, the police and public safety personnel have the opportunity to enjoy enhanced wireless service for their mobile data terminals and other devices that are used as a part of their everyday functionality.
Another question here for the City of Philadelphia and NextG. How long was the application process, presumably for the license, from start to finish? And can you explain the financial transaction between the city and NextG in the license agreement?
Why don't you start that?
We filed our, I think it was about 13 months to finalize the right-of-way use agreement and license, and the pole attachment agreement followed in queue. I think that there were some efforts to better understand the likes of DAS as the city entered into the agreement, but that was a fairly standardized agreement through an administrative process path. So that was a critical gateway factor. Do you want to discuss the?
Well, for the right-of-way use licensing agreement, there is an application with an application fee that's standard. The fees there, according to the ordinance, are primarily were prepared in relation to underground use of the rights-of-way. We do have fees for the aerial facilities. However, they have not been updated for some time, and they are the subject of discussions for reconsideration in the future, but they're relatively low. The significant fees are with respect to use of the city's own streetlights, and in this case what we did was to arrange an annual fee that would be paid by NextG, but we also established an amount that would be related to the cost of the infrastructure that they were providing to the city, and allowed them to build credits that could be applied towards half of the other pole use fees.
I actually had another questioner who was interested in fees also, so maybe I'll just pose this to the other two. And I realize fees are an individual thing, and I don't want to get into a discussion of, what is the best way to assess fees, and certainly not what is a legal way to assess fees. But were there any issues in your communities regarding access fees, and if so, how were those resolved?
Well, the issue of fees is certainly a complex and controversial subject matter. But I will say this for the town of Paradise Valley, that their purpose and objective was focused on broadband delivery and better service for their community. It was less about fees, although we have a contractual arrangement with them. There is a reduction in the fees as we add additional tenants to the network. So again, their objective was broadband service over fees.
Okay.
city has a master permit process that all utilities follow, and that does have a fee, but it is fixed. And then there are the application fees for the actual right-of-way permits, and that was the extent of it.
This question was directed to Carmen in regard to Charlotte. The questioner says, you mentioned that the nodes are in the business district. How does the DAS system enhance the business district, which was one of the topics this morning?
Sure. The half of our system is in the central business district for downtown. For Charlotte, it is becoming it is a banking center in the region. It's very fast growing. A number of Fortune 500 companies are operating there. And there have been some studies on the density, the capacity, the coverage of wireless service in downtown Charlotte, and it has not been good. So the city, I think, recognized that there was a need and that we came to them with a system that could support multi-carriers, and that we had a committed tenant, I think, was very important to them. And so with that, being there in Central Business District, that the city recognized that what we were saying about a coverage gap was true, and that they were interested in alleviating that.
Anyone else want to speak to that topic, what this meant in your downtown area?
I'll just say we don't have a downtown area, but we have 9 world-class resorts that where people come. That's our only industry, is residential and then resorts. And so we recognized very clearly that tourism is our backbone, our lifeblood. And if people don't come to these resorts, and when they do come, they want to take pictures. They want to send these back to their friends and family, and so having the ability to have expanded cell coverage at these resorts was critical for our continued industry of tourism.
I think with respect to the City of Philadelphia, I think the initial objective was to provide coverage for a new wireless entrant, but over the evolution of not only the deployment within the metropolitan area, but I think industry-wide, there's been more emphasis on enhancing network performance to include capacity. And so some of our subsequent deployments have been much smaller in number, but specifically targeted, for example, at Temple University and so forth. Not so much by the university, but serving the university, if you will, from the public right-of-way inward. So DAS obviously helps to accomplish that to a significant degree.
I can mention also that even before NextG came to the city had inquired of this cellular providers to develop a network that was similar to DAS, but we didn't know the term DAS at that time, to provide coverage in some of the Stream Valley parks in Philadelphia, where there's terrain with very steep slopes, and there was very poor cellular coverage in those parks, and it was considered to be a safety issue. And the city wanted to see that there would be better coverage provided in those areas. And so we had explored, before NextG came into the city, the possibility of some deployment. That never actually happened, however.
Great. I think if it's okay, we'll just throw you a couple more questions and then sort of wrap things up. Maybe I'm going to put you on the spot a little bit here, but I think one theme I've heard running through all of your discussions was that a couple of the key things to making everything work were, first of all, the commitment by everybody to the process, and also the clarity about, what are the requirements, what are the goals. What I'm going to ask you at this point, were there any times when those things broke down, and if so, how did you overcome that and get the process back on track?
Every operator, every provider wants to understand a degree of predictability, and I think it's incumbent upon us to help educate city staff and representatives, and as well as other players in the overall process, and to keep them focused and understand that this is oftentimes something new, something different, something unanticipated, and to the extent to help catalyze the energy and attention towards a goal of getting the equipment up, getting the project launched, and focused on the next phase. Again, the city of Philadelphia was greatly helpful and if even proactive in availing their pole infrastructure. I think it's fair to say that the likes of an XG and DAS were something that was unfamiliar to the city, but the city did work with us. We spent a lot of time educating them, making presentations to a variety of different levels within city government, from those who take care of the streetlight poles all the way up to the elected representatives on the city council. So I think that helps generate a lot of critical mass to help accomplish certain steps that are necessary for a deployment, particularly one of the size of that in the city of Philadelphia. So I think it's just a question of patience and perseverance, frankly.
But I just want to add, the reason this theme, I think, keeps coming up, and there was no collaboration on our part prior to this panel about this theme, but it may not be obvious it is to those of us who are in the business, but it's worth saying straight out that this is a business. And cities may not even realize the degree to which it's important to us as business people that there be predictability. Because this whole process starts years and years in advance. The carriers know where their gaps in coverage are. They know where their capacity needs are. And they map out strategies for filling them. They come to us, one of the DAS providers, and say, give us a proposal. If we can't tell them how long it's going to take because we don't know what the process is, there's no ordinance on the books, there's no predictability, they're not going to buy. We can't convince them to put up a DAS network if we say, we'll charge you X and it's completely open-ended. We may deliver it in 5 years. We have to work that out. So it's a critical component that cities understand the degree to which it fosters the development of this business if there's predictability in the ordinances and codes.
Yeah, I think a lot of that unpredictability is really a case. If you look at ordinances today, there were really many of them written well before the awareness of DAS that may be an option for wireless services. Because of that, you're seeing ordinances written that make it difficult for DAS to be deployed in public rights-of-way. They make it difficult for DAS to be deployed in residential areas. And although it may be the best solution, that's because of the narrowly focused ordinances really prevent a more collaborative spirit from the very beginning. And I think if we can work and educate on a broader scale those jurisdictions about the option and alternative that DAS provides, that maybe some of those barriers could be removed and facilitate a more open discussion about solutions.
In the city of Philadelphia, we have a committee of highway supervisors, which is made up of representatives of several city departments, as well as every right-of-way user that chooses to participate. And that is a forum they meet monthly, and the idea is to coordinate efforts in the right-of-way, to share information about construction plans, to discuss in advance any initiatives for new regulations or modification of regulations. And that is a way that the city of Philadelphia has tried to see that there's an understanding of the objectives both from the private side and from the public side, and to seek common solutions. When we were working on the right-of-way management ordinance, one of the determinations was to set up a working group within the Committee of Highway Supervisors to try to work out a plan that would be acceptable to the industry as well as to city officials before going to City Council with an ordinance. And I think that although it does not directly apply to the work that NextG did in Philadelphia, I think that it set the stage somewhat for expectations within the streets department among the people who were working on this of, you know, the collaborative approach.
Again, you know, within the city of Charlotte, that they did have a fixed timeline that they applied to all public utilities, and for our customer, that was very important. That I could point to the code, well, when they questioned me about timelines or that sort of thing, I could say, well, no, here it is, it's in black and white, and there is something to support that. So that was very important to our project. Additionally, I'm sure that we had some, you know, with all construction, there are hiccups, fiber, and, you know, maybe somebody is working a little bit too late or that sort of thing. But I think that, you know, again, the collaborative aspect that the city, that frankly, we built up trust with them, that we answered every one of their questions. When problems did arise, that we were quick to act on them and at least give them a plan to resolution, if not fixing it outright. So I think that we built up that track record, and that was to our benefit.
I have a follow-up question to what you've all just articulated so well. We absolutely hear a theme here of collaboration and education and mutual understanding. I'm assuming that the education process was not just one-sided. It wasn't just that the city officials needed to learn about what you were bringing to the table, but that you and the industry needed to learn about the needs and the concerns of the community. Can you speak to that process and what kinds of things you needed to be educated about in order to be able to work in this collaborative way with your partner communities?
If I may, part of the public outreach or process, as we described earlier, did involve both sides. So there was a giving of information from the town, and there was a giving of information from Crown Castle. Part of the public outreach process involved one-on-one with residents, workshops with council and the commissioners, and then neighborhood or open houses. All three of those gave us an opportunity to learn specifically what the preferences of the commissions were, gave us specific ideas about what the council wanted to see, and then more importantly, it gave us a wide or broad idea about what the public was interested in and what they moved to that town for, what was important to them. When they say aesthetics, what exactly does that mean to that person who lives next to one of the nodes? So that was a critical element. I think that over 15 public meetings that included all those elements, we were able to reach a consensus on what that best plan could be and was for the town of Paradise Valley.
Well, in Charlotte, we did have a defined process, so that was very helpful. But we did do outreach at many levels of city government, from the mayor's office to with Crudy's team, with other departments as well, public safety, and then the city was very open in inviting other departments, not rights of way, but the street opening, there's a streetcar project and other departments as well, that we have DAS that they're going to be operating in the right-of-way. It's something new. And so they were very good cheerleaders in making sure that other departments at the city were aware of our project and how to make sure that if there were other aspects of our build that might affect other city departments in ways that neither one of us, that the city and we did not anticipate. So that was good. And then the city also was instrumental in, they have a relationship, a very good relationship, I think, with the pole owner, and were very good about bringing us all in a room. And we had several of those meetings to just flesh out, okay, let's have an update on where we are on the build. What are the pole owners' issues? What maybe some other issues that the city had raised? So that sort of thing. And again, from our perspective, we didn't have a public hearing process. It was permit-based, but we did have many open meetings between the city, ourselves, and our pole owner.
I think our experience in the city of Philadelphia was very similar. Our meetings with the pole owners to include the ILEC and the electric utility were not in conjunction with the city, but often touched upon the same issues. And I think the common themes were communication and responsiveness. And I think one of the lessons learned, you remember that the city of Philadelphia is obviously a very old city, but there are many neighborhoods where the poles are really right at the edge of the curb and the sidewalk because there's very little front setback. So one of the lessons that we learned was that to empower our field crew to address issues as they arose in the field, to prevent them from escalating either within city government channels or through our channels that obviously would somehow intersect at some point. We actually spent a lot of time educating our field crews, again with the door hangers, the 24/7 telephone line. We had very few incidents where citizens would call to complain. We talked about the responsiveness and so forth, and the element of curiosity. But when issues did arise, particularly within city government or within neighborhood associations, we were very proactive in reaching out to them. Again, the equipment is designed to blend in with the streetscape and did not cause a lot of controversy or conflict. So I think that was a successful effort.
On a generic note, certainly it's true, if that's the question, that every city is unique. And there is much, if you're going to be successful, that a carrier like any of those at this dais has to do in advance. We have to understand the political sensitivities of that place. You need to understand who the utility is and what their restrictions are, what the physical infrastructure is that exists, and all of those elements, as well as an analysis of existing codes, maybe suggesting ideas for revisions to the city in advance in light of this project. All of that has to be done in order to be successful, because each place is unique.
Yeah, I think we'll just move on to a couple more things and wind up. But the question here is, and I think it applies to a greater or lesser degree, but how we deal with multi-jurisdictional issues. I think, well, all of the panelists actually are working in areas where, if I understood, there are, multiple jurisdictions in the area with DAS systems. I don't know how much it becomes an issue, the working across jurisdictional lines, but to the extent that it's come up, if you could address how you've worked through that.
With multiple jurisdictions, that typically happens with the larger deployments that you've seen today and elsewhere. There is great complexity that's put on the provider to deploy. And sometimes the only way to get through that is either on a one-on-one basis with each of those communities or jurisdictions. However, there are various organizations that kind of bring each of those communities together. And in fact, we have a Southern California deployment that we're able to take advantage of a local area Orange County organization that really speaks to the importance of broadband services. And I think having those jurisdictions that head up that organization really gives us some additional credibility with other jurisdictions that don't participate. And I think hearing from a fellow jurisdiction just really makes doors open for us as well as for the community to see better service.
Our downtown Charlotte build, we did not have that issue, but in building and working on systems now where that has been an issue, that we've had a similar experience, that we've had the best success when we go out and meet with each of the individual municipalities individually, and then they want to know, well, this is a big build, so aren't you in the town next door? And, well, yes, we are. And who are you dealing with? And again, to be upfront and say, this is what we've told you and expressed with you is what we're expressing with them. And if you'd like, this is my contact person, and you can confirm with them. And with that, again, we gain credibility and have had great success with some very difficult neighboring jurisdictions that were hard-headed, frankly, together. But then they saw, well, we have similar issues. You have American Tower coming to you. and they're approaching you in the same way. So let's kind of put our heads together on this is the approach. And then for us, there is some continuity in that we know that this is how the towns will approach it. But we do find that towns do talk to each other. And you want to be clear in the way that you're presenting yourself to one is how you present to all.
I think it depends a lot on the regulatory environment. I realize that that's off topic here, but in our experience, for example, in Greater Philadelphia, we expanded our network well out into the suburbs, as well as across the Delaware River into Camden and some of the outlying townships. And there is to a certain degree, a degree of familiarity as to how municipalities and jurisdictions would matriculate this type of deployment. Clearly, there are opinion leaders within municipal government. There are those who choose to dedicate, and perhaps Paradise Valley is an excellent example, where they dedicate their resources to perfect the model and to invest in the process, and then neighboring jurisdictions who perhaps don't have those resources then can look to the model that emerges, for better or for worse, within the greater metropolitan area as a frame of reference. So our experience in Philadelphia, for example, there was a high degree of homogeneity in terms of the process path. We were treated as a utility. We were attaching to existing poles by and large. They recognized that there were coverage and capacity issues. Perhaps it was through a formal application process and or perhaps a formal meeting to discuss our project scope, perhaps some photos or photosims, some targeted locations and so forth. Everyone wants to understand the degree of impact within a certain jurisdiction in order to be able to not only properly advise, but also perhaps stave off some citizen conflict and so forth. Fast forward to other regulatory environments, for example, where the process is very standardized, where it is very clear and concise, and so that there is a high degree, perhaps as inspired by a state statute, whether it's a registration process, a formal agreement, and so forth, where every municipality, by and large, administers their access to the public way largely on a consistent basis. So I think it really comes down to, as Robert mentioned, understanding the local codes, doing your due diligence, reaching out to the municipality, asking them to identify that process, and where there are points of contention, reaching out and trying to finalize what that process path is, so then you can begin to start the engineering and actually get the installations up on air.
And as Christopher said, a key word there was opinion leaders. In our experience, in every one of the large builds that NextG has done, it's been very important to identify the municipality or municipalities that tend to be the leader in the local, say the Regional League of Cities organization and so forth, that has an agreement already in place. So when we began a large greenfield build in San Diego County, we had an agreement first with the city of San Diego, and it became critical. And then we did one with Carlsbad, which then became the model for several others, and we ended up with some 24 agreements in the county. So that kind of patterning is quite important.
Is there anything else you want to cover? Okay, before I move on to one last question, I would note that there's at least one person, who's expressed a concern about the health effects of the RF emissions. I just want to note I don't believe any of our panelists are experts on that issue. It's not something that that we're prepared to address. I would simply note that the FCC has guidelines on that, and that everyone who uses the spectrum is required to comply with those guidelines. One final question that I was asked to pose, and I understand Alex Gamoda is going to come up and address this one, but the question is, what is the difference between DAS and small cell technologies, and are they complementary or opposing?
Good afternoon. Yeah, it's a great question. I'm glad that that was raised. Earlier in the day, there was a presentation by Jim Seymour of Alcatel-Lucent, and he provided this this slide right here, which I think best really addresses the question, which is femtocells, picocells, DAS, small cell architecture. You can add in the list tower sites, rooftop sites. And I think the way he said it is similar to the way that I would say it and answer the question, is that they're not opposing each other. They're very complementary. They're just another tool in the tool chest to try to provide coverage or capacity for that particular area. I think in this slide right here, you can see that he talks about a home small cell. You could possibly replace that with femtocell. And that would be something that would be geared really for providing coverage or capacity within the walls of your own home. You know, not to get too technical, but you'd be providing the power typically, and you'd be providing the internet connection. Then as you go into the picocell environment, maybe that's what he's calling the metrocell. And again, depending on how much capacity you're trying to get into that area, that might be suitable. Or you may want to go the next step, which I think would be a DAS sort of application. So again, I don't really see it as any one of these are opposing each other. It's just another way of providing coverage or capacity really specific to what the objective is of that wireless provider. Having said that, I'd open it up to the panel here to see if they have the other thoughts on that.
Well, I'm not sure that what the questioner had in mind, but there's a technological difference under the hood, of course, in those terms. When you use the word DAS in a traditional sense, you've got an antenna that's distributed out with a maximum range that's limited by the fiber capacity to maybe 10 miles, and you've got a piece of translator equipment, but all of the computing power is done at the base station, whereas a small cell site is a different architecture because it takes that computing power out. It actually has a very compressed, shrunken down cell site in a remote location. So there are different architectures, but I don't think that there's anything antithetical about the two terms or that they oppose each other in any way.
You know, I'll just say we had so much pent-up frustration in our community wanting better cell coverage that when this was finally deployed and we were online, driving around, cell service was wonderful if you were with the anchor tenant. But within your home, it wasn't necessarily improved. And I learned something today. I did not know that thermal windows block RF. So maybe that is part of the problem. But so a lot of our community, you know, when you're driving around, you're walking around, it's great. But inside the homes, because we have mountains, because we have stucco, because we have a lot of windows that, because of the heat, we have a lot of thermopane windows. People have found that they needed the small microcell in their home to get better service.
Well, I think we're coming to the end of our time, so I'm just going to wrap up, review the little bit of a wrap up on the day. I know I've learned an awful lot today, and I hope everybody here has learned a lot too. First panel this morning, we learned about DAS and small cell technologies. We learned about the infrastructure that they need and the types of permits that they may require. These are the kinds of nuts and bolts that we really need to understand before we can move forward and develop effective processes. On the second panel, we discussed how these systems function in different types of situations, the benefits they can bring. Now, of course, I don't think there's no one individual or organization that's likely to face all of the situations that came up in that panel. But I expect that many of you will have learned at least one thing that's going to be valuable in a situation that you face. And then finally, this afternoon, we learned how the governments and private companies in 3 communities have worked together to deploy outdoor systems. I was very impressed by these success stories. Now, certainly every locality is different, and no one model is going to work for all. But again, I expect that many of the experiences that we've heard about can be instructive to local governments and private communities across a variety of situations. As our panelists this morning told us, you know, DAS and small cell systems are not the panacea that's going to solve everything. They're not for all situations. We'll certainly continue to need the traditional macro networks as well. But as time goes on, we're seeing more and more situations where DAS and or small cell offer the best and the most efficient means to provide new services or to enrich existing services in both indoor and outdoor situations. I hope that what you've learned today will help all of you to capitalize on these opportunities where they arise to the benefit of your citizens and to the benefit of everybody. Joanne, do you have any final thoughts?
Just a quick thought on behalf of NATOA to echo everything Jeff has said about how extraordinarily informative the day has been, and how we're particularly grateful to all of you, all of the speakers, and to the FCC for all of this work in enabling all of this education to take place. The part about education and determining really good methods and practices and processes is a big part of our mission within NATOA. It's something that we do on an ongoing basis, and one of those areas is wireless facilities siting and local government processes around wireless facilities. And over the years, we've had some terrific private sector partners among companies, carriers, and associations, and we really do reach out to all of your companies to partner with us in local government in determining best practices. We saw here today 3 really excellent examples of communities that created processes that were defined and predictable and worked really well with the private sector, and the private sector respected those processes and engaged them. And if we can determine more of those and educate all of us about them, we'll work together much more effectively on broadband deployment. So thank you very much to the FCC and all of you.
I have a few thank yous of my own also, and I certainly don't want to try to name every individual who contributed to the success of this day, but I do want to highlight a few. First of all and foremost, thank you to all of our panelists the entire day. You've all been wonderful. I want to Don Johnson and Dana Beta, both of my staff, who have taken this thing all the way through from beginning to end, working long hours on it and, really getting involved in all the details to arrange everything. Charles Mathias in the Wireless Bureau front office, who would tell us when we were, maybe getting a little bit too grandiose in our ideas and get us focused down again. Cecilia Solhoff, organizer extraordinaire, who's brought her great wealth of experience. Want to acknowledge Jeff Reardon and our AV and IT staff. We've posed a few challenges for them here, and they've come through. I want to thank PCIA for helping us with identifying many of the panelists, particularly the first panel this morning, and putting that together. And of course, last but not least, Joanne and Steve Traylor and NATOA. We've talked a lot about collaboration and partnerships in your communities. This has truly been a collaboration between the FCC and NATOA, and we look forward to doing this a lot more often. Just a reminder, all of the handouts and presentations from today either are now on the FCC website, or if they're not, they soon will be. It's at www.fcc.gov/events. At this point, you'll have to go into past events and then click on this workshop. And I think we're going to be posting the video there at some point as well. So, if you know anyone else who would have benefited from this workshop but couldn't attend today, spread the word. Finally, I just want to sneak in a word or two about our coming attractions. We're in the preliminary phases at this point of planning 2 more workshops, which we hope will follow later this year. First, we want to do something that was similar to what we did today, focused on co-locations, to talk about what they are, when they're used, and local processes that have addressed them to the satisfaction of both the community and service providers. And after that, we're looking towards a forum where we'll bring together representatives of local governments and of private industry again to talk, drill down a little more on their respective needs in the regulatory process and how they might work together to develop some best practices. Please watch our website for more information as our plans take shape. For those of you who may be traveling this afternoon, have a safe trip, and to everybody, good luck as you continue to work on these important communications issues. Thank you.